Hello. My name is Rosalia Vargas. I am the director of the Pavilion of Knowledge, this place where this session is held. So we are very happy to have this brilliant person here in our Pavilion of Knowledge. Even I can't think in a better place to have this CMU Portugal than this place, the Pavilion of Knowledge. So you are very welcome. I will be very brief, but I would like to take this opportunity, first of all, to say that some words addressed to our Minister, Manuel Heitor, but he's so familiar here at the Pavilion that I forgot to start by you. Okay, but I would like to say a special regards to Inês Lins and Nuno Nunes and José Fonseca de Moura as program directors, and also to say hello to everyone who is following this session from different parts in the world. So you are very, very welcome also. CMU is a very special program, as we know, full of brilliant minds. Is a doctorate program, but I would like to call your attention to a special group that are about to start classrooms this week. Of course, I'm talking about the students from the primary school to the high school, and even to the first years of the university. They are about to start their school year. And this is a very important moment. We know how it can change dramatically the life of especially the young students. And dramatically in two senses, I think, the bad and the best one. All of we were students in different grades, and we know how important is this moment and how we can contribute to make it better. So my idea or my invitation to all of you is let's go working together for the success and the joy of the young students on this regard. Because we are talking about information and communication technologies, and this is cutting edge in our days. It's because I would like to bring to you this book, and I suggest really, because Martin Herwig wrote this book called Once Upon an Algorithm. And it's very, very interesting because he goes by the stories from our childhood, and through these stories he talks about the importance of this area in our lives. He goes through, for example, through Harry Potter, through the film, the movie Back to the Future, to the Indiana Jones, or Sherlock Holmes, or Hansel and Gretel. So it's very, very interesting, the book, because he's writing to the youngsters, to the kids, even though through the teachers and through the parents. Because he says that, for example, It's difficult some days describe computer science and everything related to these studies. And he said one thing that I'm sure all of we know is that describing computer science as the study of systematic problem solving. And this is where we are when we receive the kids here at the Pavilion of Knowledge. We invited them to solve problems. Is inquiry-based science education. And we hope in the near future, when they grow up, they will be extraordinary person as human being, but full of knowledge, that this knowledge you are contributing now to expand. So thank you so much.
Thank you, Rosalia. I would like to ask Professor José Paulo Esperança to say a few words, the Vice President of Fundação para a Ciência e Tecnologia. Thank you.
Good afternoon. Apologies for arriving late. We are not very much used to presential meetings anymore, and so I miscalculated the time to get here from FCT to Ciência Viva. It's a great pleasure and a great honor to be with you and to welcome the students of this program. I would like to mention that you are part of an important project that in the broader terms goes by the designation of Go Portugal, in which the cooperation between Portuguese universities, and we have here the representation of many engineering universities in Portugal and from other fields, and Carnegie Mellon. And this cooperation, which also includes a cooperation with MIT, UT Austin, and other international cooperations with German institutions and other entities, has been paramount in part of the broader effort to increase knowledge and science in Portugal. If you look at very simple data, like for instance the number of publications or patent registration, you usually see that there is a multiplication by a factor of 3 when you compare current situation with let's say 2000, the year 2000. So at the turn of the millennium. So there was an incredible progress. And Carnegie Mellon in particular, and this experiment is associated also not only to the creation of knowledge, and of course this dual Ph.D. program is a very, very important institution, but also to the implication in terms of innovation. And this is truly remarkable, because if you look at a very simple statistic about I don't like to focus only on very valuable startups or large firms, but indeed the topic of unicorns has become quite relevant. And the truth is that if you look at statistics from just 2 years ago, there was a mention that Portugal was number 4 in the creation of unicorns after the UK, Sweden, and France, immediately after. And this is truly uncommon, and it is very much the contribution of CMU and of this program, which only led to the creation of several of these high valuable firms in Portugal, and even some outside of Portugal, like Mambu in Germany, which is very, very significant. And Monday, we had a very, very interesting description about the impact of the technical university, and not only that, but many of the people who are now leading the program in shaping the evolution of science in Portugal. I will not take much longer, just to acknowledge how impressed I was when I looked at the topics that the PhD students are going to speak about this year. Some of them are a bit beyond my usual zone of comfort, but indeed I was very impressed that we have artificial intelligence applied to many, many different problems and situations. We have for healthcare a number of very interesting studies. We have one that is about human capital role in innovation. We have coding, internet congestion, optimal hardware, quantum computing for sustainability, thoracic pathology screening, medical diagnosis, IoT for health monitoring, and many other topics that really are very important topics. So I do believe that this generation will contribute to the efforts that 125 students before you have already done. And I must end with just stating that for science and for FCT, we are very keen on both fundamental science and both applied science, because both can have a very important contribution. So congratulations for choosing these topics, and all the best in your program. Thank you.
So good afternoon, everyone, and good morning in Pittsburgh. So in the name of the directors of the CMU Portugal, José Fonseca de Moura, Nuno Nunes, and myself, Inês Lins, I would like to give you my warmest welcome to this session. And congratulations, of course, for being here, because you are part of a very special program, and you should be very proud of it. A simple message is the only thing that I would like to leave to you, is that these are, maybe you already have that impression, but these are part of the best days of your lives. The PhD, it's an incredible adventure, something similar to the students and to the kids, as Rosalia was mentioning, when they start the first year and they know in primary school that they are going to learn how to read, how to write, and this is something similar in, well, more advanced, but you will always remember the days when you were doing your PhD, when you started, well, there are also some hard things, but this is hard work, what we ask you, and this is part of it. So we'll have this afternoon or this morning, depending on when you are, to focus on what you are doing to change experiences and to see that this is an incredible journey. And yet the better is yet to come. But on the other hand, please take the maximum out of these few hours, and you are very welcome. So now I would like to ask our Minister, Manuel Heitor, to give you a few welcome words, and thank you for your presence as well.
Muito boa tarde a todos. O mais importante é ouvir os estudantes, so I will be very, very brief, and thank you very much for your commitment to meet during these parallel sessions in several parts of the world, certainly in Portugal and in Pittsburgh or elsewhere. As it has been said, and most of you know well, Carnegie Mellon Portugal Partnership, and above all, the doctoral program has been created essentially as a network of opportunity, essentially to help training the leaders of the future. And I believe, and I would like very much to call your attention for this. This is essentially an opportunity for you to create networks which should take you to a completely new frontiers of knowledge. We know that the PhD is an hard work, but if you want me any recommendation, take always the most difficult questions, the most difficult and surprising issues, and particularly the most relevant problems that no one knows how to solve. A PhD is exactly that, is to try to be leaders in the area of your own PhD. Be the best of the world in doing your PhD. And when more than 15 years ago we started this program, was essentially to make sure that students from the best Portuguese institutions could meet the best students in the other side of the Atlantic, particularly at Carnegie Mellon, to really being leaders of the future. The difference is that 15 years ago, when we started this program, we didn't know if we would succeed. But now we have data and we have cases that we know this is possible to be done. It's possible to create out of these programs leaders of the world and the best people creating new technologies, new systems. And they start with a PhD program, and then if you are really the best, you will probably change in a different specific sector of market. I believe I see in the audience Nuno or Paulo Guedes from FITSAI, and I'm sure you will have the opportunity to discuss with him how someone that was a professor or training PhD students in this program can today have a world-leading company, probably in an area which is different from the area where the PhD was started, but the knowledge base was acquired in a PhD. So, thank you very much for your mobilization. You are not in just one more PhD program. You are engaged in a PhD program so that you can be the best of the world in the areas where you are creating. And now what we want is to do always to do better and better. And your task, together with our professors in Portugal and in Carnegie Mellon, is to guarantee that you can really understand the key leading issues, technology and knowledge base, particularly in the area of advanced information and communication technologies that will drive the world in the years to come. But try always to be different, to be the best in your areas. And again, the Carnegie Mellon Portugal is an opportunity for you to build networks and to really become the best in the world. And this is a very challenging task. It won't be easy. It will not happen overnight. It is not just a question of registry in the program. It's certainly hard work. But what we know is that hard work which really recompensates and is worthwhile taking. Telling this, let me thank all the people that have made this program and over the years possible. This is not appear overnight. It is a long path behind all these sessions. First and foremost, let me thank certainly all the program directors, the PhD program directors, the schools and institutions where you are registered, which are your home for doing research, but certainly also the program directors at Carnegie Mellon. We are already in the fourth generation of program directors, started with Vítor Barroso, then João Barros, João Colares, and now Inês and Nuno from the Portuguese side. From the Carnegie Mellon side, we still have a very young and bright student. He's always a student, José Moura, that keeps a long history, and he will tell you why he keeps so young by always being attracted to teach and to work with the best students. But we pursue year after year, trying to keep always in the leading edge of advanced IT systems, and that is our role to facilitate a program for the best of the best. So thank you very much and enjoy the program. Thank you.
about search-oriented conversational assistant. And we'll have 10 minutes and then 5 minutes for questions on each talk. Okay?
Should I start?
Yeah, go ahead. You can also take off the mask.
No, it's just in the...
okay.
Is working? Now? Okay. Okay, hello everyone. Good afternoon. My name is Rafa Pose. Before starting, I'm noticing that the PowerPoint, the format is a bit misplaced, so if there is any mistake, that's why. So, I'm Rafa Pose. I'm a PhD student from Instituto Superior Técnico. I started my PhD in February of this year after doing a master's in aerospace engineering. Now I'm working in ERIs, in the Human Language Technology Lab, and more specifically in the project Maya, Multilingual AI Agent Assistance. Before starting, I'd like to thank all the organizers, CMU Portugal and everyone else involved for the opportunity of being here, talking with you, showing my work, and also listening to everyone else. So, as you know, the presentation that I'm going to give is about my work, search-oriented conversational assistant. It's the work I have been doing for a couple of weeks, a few months maybe. So let's start. To begin, I'd like to talk with you about the difficulty of conversations. So when we speak, it seems very easy, but when you try to get an AI, an agent, to do that, you start to see that it isn't as easy as you thought. First, the conversations are highly context dependent. That means that something you say now will depend on what has been said, or maybe even what you are going to say next. So words can have different meanings depending on the context. Then, in Maya, we are focusing in customer service. So the answers that we are going to generate have to be accurate and correct. So we have to be careful about that. And then we are trying to help international customers, so our models have to be multilingual. So if one language is difficult, many languages is even more difficult. The first problem, I told you, it was the context. I'm sure everyone knows what context is, but essentially words can have different meanings depending on the neighboring words. So our AI has to be able to do just that, to understand the meaning of a word given the other words around it. A simple solution would be to simply give the entire conversation history, and our program would be able to have everything that has been said. So, the hardware that we currently have at hand is not capable of processing everything and giving a good response. So what we can do is do something called question rewriting in order to make our queries, our questions, context independent. I have here an example to show just that. So it's just three questions from a conversation. So the first question, it will stay the same. From left to right, it will stay the same because we have no history. But the second question, you can see that it ends on required to become one. What is one? When we do this question rewriting, we see that one refers to a physician assistant. So we can process this conversation in order to make each question independent of the previous ones. And the last example is what does it cost? It refers to becoming a physician assistant. And so if we replace the pronoun by the entity, we can just feed that one question and the model can go from that. And this is obtained with a transformer model, so this is actually output of a model. Then the second problem that I told you was the knowledge. Our answers have to be factually correct, and so we have to give knowledge to the model in some way. One way would be to simply use the knowledge that is implicitly encoded in the model parameters. For example, a neural network will have its weights and it will have some implicit encoded knowledge. But another way, and maybe more explicit, is to do a retrieval process. That is, we receive a question, for example, what does becoming a physician assistant cost? Then we will have a model that will, for example, search the internet or a series of documents and retrieve the ones that are relevant to this question. And then we will use that information in order to generate a response to the initial question. And this is particularly useful for factual knowledge because the facts are there explicitly, so it's much easier for the model to use them. The last point would be to generate a response. So we have a question, we have a relevant text that will aid the model to generate the response, so we just have to answer. As an example, I have here a question, what is a Maya, the project that I just told you about, and then a small text passage. And a possible response would be, Maya is a large-scale research project. And this response can almost be seen as a summary of that text passage. So in this case, if we give these two things, it can be like a summarization. And what I've been talking about is a system pipeline that I've been working on for a shared task that I'm participating. But just to recap everything, so we get a question, we rewrite it in order to make it context independent, and then we retrieve text documents that will aid us in the answer generation. And then with the question and the relevant passages, we generate a response that will hopefully aid the user. I trained this system. I have some plots here. You don't have to pay much attention. It's just to show that the model is indeed converging. So the loss is decreasing as expected and desired. And this automatic metric called rouge is also increasing. So it's all good. But to get a sense of the results, I have here a small conversation that I got with this model. So it's the output of the model and not something handwritten. So I asked, what is tofu exactly? And the model generated, tofu is a soy-based, vegetable-based, protein-rich alternative to meat in many Asian recipes. So you see that the model is indeed using facts and knowledge. And then how is it made? Notice that the user asks it and not what is tofu made. But the model still gets that it refers to tofu and answers correctly. And then I can jump maybe to the last question, what is the best tofu, that I found very funny and interesting. The model generated the best tofu I ever ate was from a restaurant called Little Buddha. So it appears like the model even had the experience of eating in a restaurant, and I found it very interesting. Then, since I'm working in the Maya project and it is related with customer service, I tried this same system with a community support dataset called Ubuntu Dialog Corpus, which is a data set about Ubuntu-related questions. And I have here also an example. A user is having problems with their hard drive, and it asks the system, and the system generates from scratch what do you mean, and so on. And in the last result, in the last output of the model, it even gives a command that would help the user and is actually correct in Linux. So yeah, this kind of system appears to work very well. And so to conclude, I confess that these results are a bit preliminary, but they already appear to be very promising. There are still lots of work that I have to do, namely do some automatic metrics, ablation studies to see what is needed, what is not, compare with other models, and so on. And then I have also been very interested, and I've been reading about non-autoregressive generation and also embedding generation and continuous output, this in transformers. So if you have any question about the presentation or even these other interests, feel free to ask. And thank you very much for your attention. You can also send me an email with questions if you want. And yeah, thank you very much.
question.
Thank you.
If anyone in the audience has any questions, feel free to ask them or raise your hand, and you can come. Yeah. Just a second, I think someone will take a mic.
So you said something about having to rewrite phrases in order to preserve context, right? So how much history do you need in order to be able to... Did you hear me until now?
Yeah, I could hear you.
How much history do you need to preserve in order so that full context is preserved? Or do you only need the exact message before the one you're trying to rewrite?
That's a good question. That's something that I've also been wondering and doing some studies. Actually, the rewriting is not to preserve the context, it's just to make it easier for the model to process the query. Because we could also just feed everything to the model and then let it answer. But when we do rewriting, we can, as you said, we could just use a few previous sentences. We could use everything. What I have been doing is using as much of the previous questions as the model is capable of handling. That is like a restriction of the model. It has a maximum input size. But I have been using the maximum. But then there is another thing that you could do. That is, you could in the rewriting process you could use the already rewritten questions, or you could use the original questions. In theory, if you use the already rewritten questions, it should have all the information necessary, and you wouldn't lose. But yeah, I've been using as much as I can of previous questions, but it's not like a fixed rule. I think it varies the performance depending on the model. And thank you.
Any further questions? I believe there's another one.
Yeah, thank you very much for the presentation. Very nice. However, I came a little bit late, so I didn't get the initial slides. So my question may have been already answered by you. So one of your slides, if I'm not mistaken, had the number 1.8 million. Is that the number of dialogues that your model has generated? What's that number about? And the deeper question really is this a dialogue generation system, and is it automatically generated? Is it interaction with humans? How is that? Yeah. Sorry that I was a little bit late. Thank you.
It's also a very interesting question and a very good topic to address. So I think the number you saw was when I presented the Ubuntu dialogue corpus. It had about 1 million something. That is a data set of 1 million conversations, and each conversation has about 8 turns, 10 turns. And we use that to train the model. And then, having the model trained, we could use it to generate as many dialogues as we would like. But the model is trained to generate in the perspective of the agents. It is not trained to generate both user and agent, questions and answers. It only generates the answers. And then the last question you asked was, could you just...
No, I think you answered the question.
Okay, nice.
You are generating automatically the answer to questions.
From a question, yeah.
And those questions are asked by humans? You enter the system? Okay.
Yeah, and then the system generates completely automatically. Thank you.
Any other questions? Okay, I have one last question. Yes. Great work, thanks. In this type of dialogue system, usually the answer lies in the database where you do the retrieval. In cases where you have it negated or some sometimes you don't have the exact answer. How do these systems fare, and what do you think would be a solution to those type of answers?
Okay, so there are very many ways to get to the answer. You told one. It would be to retrieve an already made answer from a database. In this case, it is a bit different because we are almost like retrieving possible answers, and then we are feeding that to a model that will, it may change the answers a little. But in this case, the intelligence of the model comes from the retrieved passages. And so I would say that if an answer doesn't exist in the passages, it would just throw garbage. I mean, it could maybe give a correct answer, but you wouldn't be able to know for sure it would be correct. That's the thing of deep learning. It's almost like a black box. This retrieval method allows you to see the text passages which the model uses to base its answer. But then you can't. It's hard to control the generation. And yeah, that's also a topic that I've been working, like explainability, how to know when the model is sure about its answer or not. And it's a big problem with the algorithms. And thank you.
Okay, thanks. I think we're already running over, so maybe we can switch to the other student. Thank you so much. Gonçalo, thank you. And now we'll have Gustavo Gonçalves. And look at him. Yeah. So can you just give a little bit of introduction and so we get to know better?
Sure. Hi everyone, can you hear me? All right? Great. So first of all, thank you for organizing this symposium. It's great to be out of our home offices for a change and to be able to share our works and get in touch with brilliant minds. So today what I bring you is work that I've been spending a lot of time over the last couple of months. And I'm a PhD student advised by Professor João Magalhães from Nova and Jamie Callan, and we work on information retrieval, as you might as known as search. So my thesis topic is going through conversational search, and what I bring you today is a problem of getting computers to understand what are we talking about in a conversation. So okay, so this is working. So everybody agrees that Google and search engines has become an ubiquitous part of our lives, and I can't imagine a day without reaching out to my phone and having information readily available and with such high quality. However, the way that we see information has roughly stayed the same over the last 2 decades. So this recipe for success, which is a white page with a set of blue links, is something that's worked so far and not worth changing. We have the introduction of good information queues like entity cards, and with the pandemic we now are able to see graphs just by using a simple query. But we have trained users to work in a keyword-based search scenario in opposition to a conversational one. So when we want to express an information need, so example, COVID cases, we don't ask, what's the number for COVID cases today? We might have a couple of users that do that nowadays, and the search engine will be able to understand that, but it's not really a conversation. So the idea of talking with a search engine is possible today because we have Google Assistant, Alexas, and Siri's in our pockets, but we don't engage in deeper conversations about when we want to learn about something. So what I bring you here is an example dialogue of the CAST dataset, where we have a set of queries that might be asked about a user. The user is very interested in learning about veganism and how it impacts the body in terms of nutrition and if there will be any deficits. However, if we run these queries today, our search engine, commercial search engine, will be a bit dazzled, and it will not give us optimal results. For example, if you try to use the query, does it help you lose weight without context about where the context is veganism, you will probably get results if you try it right now about sports. So, and even if you try to put in a search session all of these queries by order, Google will still not do a very wonderful job in providing context. Moreover, in this particular task, the challenge is to give the best answer or the top 3 best answers and not the pages that Google usually give us. So my hypothesis here is that in order to maintain context in a conversational scenario, we can use the entities that are mentioned in the queries in order to give some sort of information flow. So here we can intuitively see that the user is interested in talking about veganism, the environmental impact, some nutritional impacts that it might have in itself. So for a conversational scenario where we have more than 2 queries or 3 queries in a row, this becomes imperative to maintain context. So what I've come up with, along with my advisors, is, okay, we will extract the entities from these queries and from the documents that we are retrieving, so those top 10 or 20 documents, and generate a simple co-occurrence graph. We assume that entities that co-occur in the same passage together are important and should be considered while building this information graph. So building the entity graph itself is just a binary square matrix where we count the co-occurrence of the entities in the documents. And the simplest way to weight this matrix is to use a binary approach where it occurs or not occurs. But as we will see in the next following slides, it's more interesting when we try to combine it with the information from pre-trained language models. And here is our entity graph, which will be given by the interaction of this co-occurrence matrix. So one of the challenges to model the importance of entities, and we can use centrality algorithms. I have chosen to use PageRank because I was very familiar with it, and it has very nice properties. And what we can do here is just to plug our graph into the PageRank formulation, which for nowadays standards is a very simple algorithm. And we'll get a ranking of the most important entities given the entities that appeared in the previous slide on the query side and on the document side. After that, we can just get a score for the passages using this importance vector of the entities. So we do a product between the importance vector and the passages. And the passages will have a score given the important entities. So one of the things that I've been talking about is how to maintain context. And to maintain context, we can do it on the query side or on the document side. So I've chosen to start with the query side because it's the simplest. And I've experimented with a bunch of combinations. So the simplest of them all is to use just the query the entity that appears in the query, the current query. So if the entity is vegan, I'm going to use vegan as the entity to begin my entity graph. I also try to use all the entities in the dialogue, try to combine the entities of the first query with the current ones, and using a sliding window to keep a recent context of the entities that have been mentioned in the past 3 queries. So NDCG here is a relevance metric with respect to the cutoff, the documents that we are considering, where higher is better. And this sliding window method has improved the results a bit, but these are very small improvements. So I moved on to trying to weight the matrix, and that's where the most gains are coming from, the different ways of combining the matrix. So this is a very big table to digest. So these are the 2 conversational data sets that I'm using. The first 3 rows are standard retrieval models just for sanity checking. Our competitive state-of-the-art rebranker is this BERT, and we are trying to improve on top of this. So our methods are in the bottom using the EC binary, where the co-occurrence matrix is just binary, EC BERT, where our matrix has been replaced by the original scores of our ranking. And linear and RF are combination methods based on a linear combination and reciprocal rank fusion. So The improvements of using this formulation on top of a state-of-the-art re-ranker has been very promising for the 2019 version of the dataset, and a little more modest on 2020. In order for this work to be really good, what I'm trying to do right now is understand why is this not working so well here. One of the possible explanations, and what I'm looking at right now, is that the dialogues might have changed a bit in terms of construction from 2019 to 2020, so they might not display the same properties. More interestingly, so the essence of my work is taking entities or information from lower ranked documents that we usually don't see at Google, or we don't go to the second Google page, and we take the information from those documents, those entities, and try to push them up for the higher position, so the very first 3 results that appear. And what we can see here, I want you to pay attention to the black line, which is our baseline, which we are trying to improve. And this graph 10 and graph 20 baselines are just saying that, okay, I'm building this graph with the entities from the first 10 documents, 20 documents, and 40 documents. And the interesting pattern here is actually when we include a lot of information in the graph, the results, we harm the results and we are not able to beat the baseline. Finally, I want to share this analysis with you that shows how the important entities appear in order. So this is a dialogue again, and we have a depth of 1, 3, and 6, and 8. And what we are able to see here is that the entities that appear on the top of the ranking are very related to the topic with the ketogenic diet. And as we go down the ranking, we have very generic entities that might not even be considered entities. What is interesting here is, okay, we are considering a lot of the weight in the first 10 entities that appear, and they seem, when I plot the first 10 entities on the top graph to the bottom one, we can see that there are some neighborhoods that might induce similar topics, or let's say conversation branches that the user might be interested in pursuing. So this is where I'm focusing my work now, which is to identify these communities of possible conversation branches that, and paths that the conversation might follow. So to sum it up, I've shared with you a lightweight approach that improves the results of state-of-the-art re-ranker. And our experiments show that by adding entity information from lower ranked documents, it improves the quality of the results that appear on top. And while carrying query context on the query side seems to improve results, there is room for improvement by considering the same kind of information on the passage side. I conclude my presentation, and I'm happy to take any questions. Thank you. Sure. Perhaps the mic for the audience.
What I'd like to ask is, how do you choose the entities that you use in the graphs? I don't know if you told it or not.
No.
Okay.
Great question. So, what I'm doing is processing text, and I need some kind of a tool, an entity, a named entity recognizer, or a linker. So I prefer a linker because I have a confirmation that that entity exists in a knowledge base, such as Wikipedia, and if I can then try and search on top of the Wikipedia in a knowledge graph search, through the knowledge graph. However, the way I'm selecting the entities is, from my experience, I tried some high precision approaches and high recall approaches. And high recall, by considering all the entities or a large number of entities that appear in the documents in the queries, is more successful. So that's the issue. The filtering the entities is a tough task, and I've used centrality algorithms such as PageRank, and that will give me the most important entities. And those are the ones that will drive the conversation. So it's promising that on top of a BERT re-ranker, which is a very complex and heavyweight model, we can just extract the entity information that was overlooked by this model with a lightweight approach. Was I able to answer your question?
And I don't know if anyone else wants to ask anything, but I have another question.
Sure.
do you retain any temporal information, or when you compute the graph, or when you use the entities, it's just like a bag of words? How do you retain any?
Yeah, at the moment it's just a bag of words, and that carrying the query entities is an attempt of capturing that temporal information, but that's definitely one of the next steps in order to maintain context. Thank you.
Thank you.
Okay, sure.
What's the main bottleneck of building this entity graph?
So,
is it too expensive to compute?
No, that's the beauty of the thing, because building the entity graph itself, it takes only a matter of seconds. So I can run this over 200 queries in half a minute, which is something that we are not used to. I also tried approaches with neural re-rankers that were entity aware, and those take a couple of hours, if not days, to train. So to get results, the complexity is very low, which is one of the positive sides of this approach.
Okay, thanks.
Thank you.
Okay, my question is related to the evaluation part.
Mm-hmm.
Maybe I didn't pay enough attention, but it's like, regarding the NDCG,
Mm-hmm.
like, how do you define relevance, and how do you build, like, how do you know, like, your ground truth, basically?
Thank you. That's a very important question. So the data sets that we're working with were obtained by the National Institute of Standards, and every year it occurs a competition named TRACK, where participants submit results, and the results will then be evaluated by NIST. So NIST will give you the standard and the gold standard. So they will take a sample of search engine results that were submitted, and human assessors will actually read the query and read the document and say, this is in a graded scale from 4 to 0. This is a highly relevant document, so it takes a 4. And we are very lucky to build on top of those data sets that already give us the ground truth. With that information, we are able to calculate NDCG. Thank you.
Any other questions?
It's a bit technical, but if you say in English without math, how do you connect your entity graph then to whatever you were doing at the other level?
Sorry, how do I connect the entity graph with?
How do you use the entity graph? I think that in your last slides you showed the entity graphs, I guess.
Mm-hmm.
And how do you then use that towards whatever you are doing and trying to achieve?
I see. So the entity graph itself will give us the scores. So I build the entity graph, I run the centrality algorithm on top of that, and then each entity will have a score. And that will help me score the documents where those entities appear. So to answer your question, I'm not jumping in the graph in terms of knowledge, because it's not yet a knowledge graph, but that's a step that I really want to take, because it will help me. If I navigate the graph, I can infer what will be the next topic, or I can say that this entity, for example, veganism, is related to vegetarianism, and the user might spawn a question from there. But right now what I'm doing is just taking the entity graph, getting a score out of the entities, and using those scores to reorder the documents. So to answer your question, right now I'm not using the entity graph as a knowledge graph in terms of really capturing knowledge, but more like a frequency-based approach to get scores and an estimation of that knowledge. Thank you.
I believe there's another question.
Just a very short question. In how many years do you still have for your PhD, for me to understand if you can do all that you are saying?
1.5 years.
Yeah, so be careful with the time you have for, all these ideas that you want to explore, but eventually further. But that's my only comment, which is a brilliant presentation, but be careful with the time you have to complete your PhD.
Thank you. I'm feeling the pressure. A lot of great ideas and not enough time to pursue them.
Okay, thank you so much.
Thank you.
Okay, so now we'll go on to the remote sessions, I believe. And we'll have the next student. Hello, John, can you hear us?
Hello, everyone. Can you hear me?
Yeah, okay.
Okay, great.
Okay, so thank you, John, for coming. So we'll have John Mendoza, and he'll talk about conversational quality estimation in dialogue. Yeah, you can start. If you want to give us a little bit of an introduction and where you are on your PhD and so on, it would be great. You have 10 minutes.
So, hello, everyone. My name is John Mendoza. I started my PhD program earlier this year at Técnico Lisboa and in ESCAID. I've also been recently accepted to the CMU Portugal affiliate PhD program. And today I'm going to give you a brief presentation on my PhD topic, which is conversation quality estimation and dialogues. So, as we all know, dialogue systems present themselves frequently in our lives. We have first virtual assistants that help users in daily tasks, such as calendar maintenance and weather queries. These systems typically operate using predefined actions and are voice activated. We then have also information-seeking systems that provide users with information about a question, for instance, the best hotel in town. These two systems typically operate together under a single intelligent agent, which are the ones we frequently see on our own mobile cell phones, such as Amazon and Siri. And then we also have chatbots, which are, of course, the first point of contact in many customer support chats. So all of these systems are typically powered by AI. And of course, one of the important steps when developing these systems is, of course, evaluation, which is the topic of my PhD. However, despite evaluation being extremely important in the development of these systems, evaluation of dialogue systems in particular is quite difficult, as there are many factors to take into account. For starters, the definition of what a high-quality dialogue is not always clear and is, of course, application dependent. And as such, evaluation methods must be related with the characteristics of the system under evaluation. So here's a good example I like to give, which is in the domain of flight reservations, customer support, and here we have two examples. The first one on the top tries to sympathize with the user that had missed his flight. However, it fails to meet the goal of rescheduling the flight. And then we also have the second example that actually meets the goal of rescheduling the flight, but the chatbot is quite dismissive, which might have negative impacts with the user itself. However, even if a definition is given, it's not always clear how to measure it. For instance, using the previous example, if we assume a high-quality dialogue to be defined at its capability to respond to a user in a way to increase its satisfaction, it's not quite clear how satisfaction is considered in this context or how to even measure it. As such, current evaluation methods typically rely on human evaluation. For instance, we have Alexa Prize, which is a well-known competition on chatbots, and the submissions are evaluated using coherence and engagement metrics. However, human-collected annotations are not quite reliable. So we actually employ additional techniques that we use to reduce the uncertainty of having human annotations, and this is typically used by having multiple annotators per data point. And the need for having multiple annotators, and of course the setup costs for doing this annotation, means that these evaluations are very time-consuming and expensive, which is not the best solution when we want to do hyperparameter. And of course, we have, recent literature in this topic is aware of these limitations of human annotations and have proposed several automatic solutions for them. Despite being automatic, most of them depend on the collection of human annotations and feature engineering, or then suffer from very weak correlation with human judgments. Furthermore, each method presents a different notion of quality and therefore fail to generalize for the systems, and of course makes it more difficult to evaluate how metrics are doing. Recent approaches offer unsupervised evaluation methods for conversational agents, but their extensibility to other dialogue systems, such as task-oriented ones, has yet to be determined and is still under study. Another issue with these models, as most of them rely on black box models, typically deep neural networks, which are now the state of the art in natural language processing, namely transform models. These models lack a degree of explainability, which is a downside because we could use explainability to zoom in and detect issues with generation. And of course, current research trends in dialogue point towards the use of very large-scale chatbots that take advantage of substantial amounts of data. A good example of this is GPT-3, which has been on the news quite recently. These models show impressive generation capabilities, which makes evaluation even more difficult and ambiguous. And as such, the task evaluation must evolve for this project and has reached a point that evaluation is actually one of the bottlenecks in the advancement of dialogue systems, similar to machine translation. Moving on to the goals of this thesis, we actually have 3 different goals. The first one being the determination of emotion being or not correlated with conversational quality. The second one, of course, the automatic quality estimation model, which we want to devise a new metric for quality in dialogues. And then we also want to assess this quality metric in the context of a large-scale collaborative project, which is Maya. With respect to the first goal, the idea behind this is that human agents and users interact along with the dialogue at several levels, both linguistic and paralinguistic. So by paralinguistic, we actually mean emotions, engagement, and personality. Emotional analysis and its correlation with conversational quality metrics is, of course, then a key module to zoom in and then understand the dynamics in a conversation. A good example is if the behavior of a frustrated user be neutralized, it can be even neutralized and then transformed into a positive experience if we have an engaging agent. So this positive behavior will, of course, then correlate with a higher conversation quality score, which is the main goal of these systems. Therefore, the task here is to focus on the automatic detection of the human agent and user satisfactions, as well as their dynamics throughout the conversation, and then study their correlation with customer satisfaction scoring. In the first stage, we want to evaluate state-of-the-art context-aware machine learning models that classify sentiment polarities, and then more fine-grained emotion classes in chatbot conversations. And then we want to do an objective evaluation of the correlation between the customer and the agents, and conversational quality metrics will be conducted as well. With respect to the second task, here we want to devise models that perform automatic estimation of conversational quality, both at the local and global levels. Unlike previous metrics that evaluate dialogues based on a single notion of quality, the task here is to explore the development of models that evaluate the success of each suggested response in terms of, for instance, intent, semantics, register, among others. The idea is also to perform an overall analysis of agent and user satisfaction. For this, the model will take advantage of the feedback provided by the agent and user in the form of metadata, and also the outcomes regarding the sentiment analysis studies we described in the previous task and goal. And for this, we want to leverage supervised and unsupervised machine learning models for this task, namely by evaluating response generation models, as well as more traditional methods that rely on metadata information alone. With respect to the last goal here is, of course, we want to obtain these conversation quality metrics, but of course, we want them to correlate with customer satisfaction and then use this metric as a component of a multilingual intelligent agent. The agent I'm talking about is Maya, which is a large-scale collaborative project that includes CMU, INASCAID, and Babel, and FCT, which is a part of this Ph.D. And of course, a good option when using this approach is that the information we gather from quality could be used to augment the learning process of a digital assistant or even a chatbot, so that improves its answers capabilities over time. And another important question here is that we want to assess if these metrics stand and be consistent after and before machine translation, because the conversational agent we propose is actually multilingual. So the idea here is to understand if conversational quality remains the same before and after the translation. And that is all. I hope you enjoyed this brief presentation. If you have any questions, please let me know. Thank you.
Thank you, John, for the talk. We'll take some questions first from the audience, if there's any. Okay, I have a question. So this seems like a really hard problem to measure the quality of dialogue systems. How do you plan to build this metrics? Do you have any idea already on how you would perform this, or how you will evaluate this?
Of course. So certainly there is a substantial community working on this issue. We actually have a workshop that occurs yearly, which is GEM. At least a part of it pertains to evaluation. So of course there is previous work that attempts to solve these issues. The novelty of this thesis, however, is its use as a component of a larger scale conversational agent, and its domain is customer support, which is not something we actually see very often. Typically, evaluation is conducted for general chatbots. I guess the GPT-3 is an example. We also have other examples. Alexa Price is a good example, and Convai. Or then we also have evaluation methods for task-oriented systems, which basically leverage dialogue acts and other metadata to do its evaluation. So customer support doesn't actually fit well within these two different domains. So ideally, we would like to have both worlds implemented in our evaluation system. Of course, one of the limitations and something we are working very hard right now is to have a comprehensive multilingual data set of customer support, and it's something we hopefully will have released very soon and work on that to get some annotations and start working with it.
And what do you foresee as the main difficulties that you'll have to overcome for building this evaluation system or the metrics?
Mm-hmm. That's a good question. Well, at this point, it's still very early to determine, but from what I've gathered from other systems, it's an ability to extend to other domains. So obviously, having a data set that is multi-domain will help in this regards, but it might reach to a point where you have to develop an evaluation system for each domain, which is something we have to understand better.
Okay. Okay. Any other questions? I guess there's one.
Very nice talk. So my question is to provide a little bit of context. Can you say this project, who are your advisors? And I think you mentioned Unbubble. So can you provide a little bit of the context in which you are working?
Most certainly. So my PhD is inserted in the Maya, which, as I've mentioned, is a large-scale collaborative project that includes INESCID, which is tasked with this part of the project, which is the customer support chat, the chatbot, and evaluation methods, including emotion recognition and sentiment analysis. My supervisor is Isabel Trancos at HLT, and my co-supervisor is Alan Levy at Unbabel Research. I'm not sure if I answered your question.
Yes, you did. Thank you.
Okay.
Okay, thank you, John. I don't know if there are any further questions. Okay, good luck with your work. Thank you. And next we'll have Patrick Fernandes. Are you there, Patrick?
Yeah, I am. Can you hear me?
Yeah. Okay.
I apologize for any miscommunication errors. Blame it on the transatlantic cable.
Okay, I think we hear you. We don't see you. Just a second.
Yeah. Cool.
Yeah,
okay.
I think we see you
myself.
now.
So, yeah.
Okay, thank you. Patrick will give a talk about measuring and increasing context usage in context-aware machine translation. And thank you for coming. Go ahead.
Yeah. Can I? Okay. Let's see what happens up with the next slide. Okay. It's really hard to see the slides though from here. Okay, but I think I know which one it is. Yeah. So I'm going to present my work on measuring and increasing context usage. First of all, I'm a second year PhD, dual degree PhD student. And yeah, I'm currently at CMU, and I'm supervised by Graham Newbig and André Martinez in Portugal. And yeah, my topic is also in the scope of the Maya project, working on contextual machine translation and the topics related to it. And so I'm going to present the work that was presented at the Association for Computational Linguistics 2 months ago. Okay, so what's the topic? What's the problem? Okay, let's see. Yeah, so yeah, current MT systems are mostly sentence level. By MT, I mean machine translation systems. And this is mostly done for simplicity, since the majority of ambiguity in the translations can be resolved without looking beyond the current sentence. And even when evaluating by sentence level, supposedly these systems have achieved human level accuracy, according to some works. However, when document level evaluation is performed, so evaluation that takes into account the surrounding context, they're still not close to human level performance. To see why, consider this example. We can see that the first sentence can correctly be translated without looking at any context. However, to correctly translate the second sentence, a system needs to know what noun the pronoun it refers to, so it can translate to the correct gender pronoun in German. A sentence level system will probably just relate to the most likely gender pronoun and therefore exacerbate existing biases, such as, like, for example, a he or something else. So, okay. So there have been many approaches proposed for contextual MT. I won't bore you with the exact details. Yeah. But however, most of these approaches fail to outperform baselines on high resource scenarios. And by baseline, I mean a sentence level baseline, and by high resource, I mean models trained on sufficiently large document level corpora or pre-trained on sentence level corpora. And this is both with respect to standard MT quality measures, such as BLUE, and more focused evaluations on contrastive datasets. So the question is, why is this the case? Why are they not able to outperform a sentence level baseline? So we hypothesize that models underutilize context even when able to use it. In other words, even though context is passed to the models will mostly learn to ignore the context and just use information in the current sentence. However, quantifying context use is a tricky problem. While evaluation has been proposed to measure, contrast evaluation has been proposed to measure performance on this intersentential discourse phenomena, this approach is confined to a narrow set of phenomena, and such as pronoun translation and lexical cohesion, and might ignore other ways that context might be used. Can we do better than what we do now? So the first major contribution of this work and this paper is the method called contextual cross-mutual information. So recently, Bugler et al. Proposed cross-mutual information to measure difficulty in translating between different languages. In this work, we propose conditional cross-mutual information. This is done by considering an additional variable for the context, C, and measuring how much information the context C provides about the target Y given the source X. Note I introduced two models, a QMTA, a sentence level translation model, and QMTC, a context-aware translation model. Here's an illustration of what CXMI captures context usage. When given only the source X, we can measure the uncertainty over the target language Y given the source X. When additionally given the context C, we can measure the uncertainty over the target language Y given the source X and context C. CXMI is precisely the difference in uncertainty or information gain when you introduce context. And this gives us an intuition if the model is using context. So what considerations do we need to have about these models that we introduced? So while in theory they can be any model, we're interested in removing any confounding factors other than the context that might lead to a difference in the estimates of the distributions. For example, if they're completely different architectures, it will not be clear if the difference in probability estimates is due to the context or to the difference in architectures, or training regimes, or random seeds. So to fix this, we use a single model that's able to translate both one given context and one given context. And we'll see later how we achieve this. So for experiments, we consider document level translation task, IWSLT 2013 for both English to German and English to French. We also consider a pre-trained setting with a large model. So we pre-train a sentence level model on protocol. And we also evaluate on contrastive datasets for pronoun resolution and lexical cohesion to compare our metric with traditional metrics for context usage. And just for context, contrastive datasets are datasets where you're given two choices, the correct choice and the incorrect choice, and the model gets the choice correct if he assigns a higher probability to the correct choice. So how do we train a model to be able to translate with both context and no context? So during training, we sample a random context size on the range of 0 to 4. and we sample uniformly for every example in the batch. This way, the model is trained to translate both with context and without context and with varying levels of context. And we were able to verify that this is actually the case, and the model is able to translate with and without context. And we then measure CXMI for each levels of context on both the source side and the target side context. Wait, sorry, this I just noticed. Okay, yeah. So yeah, results show that the models seem to use target side context more than the source side context, especially for the pre-trained case. And we also find that including more and more context will yield diminishing increase in context usage, hinting that there is a sweet spot between complexity of including more context and the information gained from doing so. Okay, this also shows the point by zero correlation between per sample CXMI and a binary random variable that takes a value 1. It's the contextual model picks the correct translation and the non-contextual picks the incorrect one. And we find that CXMI correlates with this previous measure of context usage. So it seems to be capturing some form of context usage. Okay, so we can answer the question of how can we measure context usage? So now the question is, how can we increase context usage? Can we find ways to increase it? So motivated by the previous results, we asked the question, is it possible to modify the training methodology to increase context usage naturally? So we propose cohort dropout, an extension of a popular regulation technique using sentence-level machine translation, word dropout, to the context-aware setting. The intuition behind interpretability is that by dropping information from the current source, but not the context, we increase the relative reliability of the context and therefore providing an inductive bias that context is important for translation. And you see, for example, for this sentence, with for example, blank out certain words in the current, but not in the context. Okay, for experiments, to measure the impact of cohort dropout, we consider the same set of models trained with dynamic context size and with increasing dropout values of P. We see that cohort dropout consistently increases the CXMI, so our measure for context usage, for models trained with it, hinting that it leads to models that use context more. And to assess the impact of cohort dropout on translation quality, which is what end users care about and what companies care about and the real world cares about, we consider, we train 4 models with increasing levels of cohort dropout, a baseline with no context, a 1 to 2 model with 1 target sentence as context, a 2 to 2 model with 1 source and 1 target sentence as context, and a multi-encoder model to verify that other architectures also benefit from cohort dropout. And we evaluate on blue and Comet, which is a multilingual pre-trained model-based metric that has better correlations with human evaluation. So we find that non-pre-trained models, cohort dropout consistently improves the performance of contextual models when compared to models trained without it, and with the sentence level model trained with the same level for dropout. And the gains are particularly notable for Comet. For the pre-trained case, improvements are not as noticeable, although models trained with cohort dropout always perform on par or outperform models trained without it. And this is perhaps a reflection of the trend that harder models are bigger models and better models are harder to improve. Cohort dropout also seems helpful for the multi-encoder model, with cohort dropouts improving scores consistently. And this shows that this method transfers to other architectures other than the concatenation-based one, which is the base one we use for our paper. In the contrast evaluation, improvements are also consistent, and we can see that in general, increasing cohort dropout leads to improved performance, particularly for the non-pre-trained case. And the same happens for the multi-encoder architecture. And curiously, when these models are trained without cohort dropout, they are not able to outperform the sentence level baseline. But when they're trained with cohort dropout, they achieve a performance slightly above the baseline, which hints that cohort dropout is necessary for this architecture to actually work, which is a curious finding in my opinion. Okay, to conclude, we propose a new metric to measure context usage and a method for increase it, and they're both architecture agnostic. We hope that future work on context-aware MT explores using both. And we also think there's some future directions exploring CXMI more for conditional language modeling and further connections to information theory. And it actually turns out that there's already works to actually do this since then. So just as a curiosity. And yeah, thank you. Code is available for anyone who wants to check out, and the paper is also available on our archive.
Thank you, Patrick. Any questions from the audience? Or, yeah, go ahead.
Okay. Hello, Patrick. I have a question. This cohort dropout that you presented, how is it different from the normal dropout?
So, for normal word dropout, I assume, because dropout is completely different. Like word dropout, this is based on the concept of word dropout, where the idea was to propose for only the sentence level setting. So you drop words with equal probability. So we extended this for the contextual setting, and we made a smart distinction where we explicitly say that the model should not drop words from the context. While if you were to apply it naively, it would just drop words from everything. And we tried that, and cohort dropout seems to perform better than dropping words from the context, basically. At least in contrastive measures or context usage measures. Does that answer the question?
Yeah, I don't know if I followed completely. So when you are using cohort dropouts, how do you select the words that you drop out?
It's just a random probability. Every word on the current sentence has a probability of being dropped out, basically.
Okay. Okay. Sorry to ask you again. So you have the normal dropout algorithm that also does that. No?
Yeah, the normal word dropout algorithm, yes, also does that. The dropout is completely different. It works at hidden states. But the normal word dropout also does that. The difference is that we extended it for the context setting, because normally this is applied to like a single sentence. And now we have a case where you have a single sentence and also context. So the question is, how do you apply word dropout? Do you drop everything? And as I said, this is a simple technique where we chose to only drop on the current sentence, but not on the context.
Okay. And
this is the difference, I would say.
So the difference is that the normal dropouts, you apply it to the hidden layers, and this one, you apply it in the input of the model?
Yeah, exactly.
Right?
Yeah, exactly. And that's the difference between dropout and word dropout.
Okay.
And the difference between word dropout and our method is that ours only applies to the current sentence.
Okay. Thank you.
Any further questions? I do have a question. Patrick, I don't know if you understood correctly. Which of the best architectures worked? Which of the architectures work best with this context dropout? Yeah.
Yeah. So we found that the concatenation, surprisingly, the literature on context-aware proposed very complex architectures, but early experiments showed that just concatenating the context to the sentence seemed to work the best for us. And this is also where we saw the most significant experiments with both CXMI and cohort dropout. But then we also saw weirdly that for the multi-encoder, where you have a different encoder for the context than for the current sentence, so instead of concatenating, actually have a different encoder, we found that if we train this without cohort dropout, in terms of contrastive evaluation, there would be no better than just having a sentence level baseline. But when we trained with cohort dropout, it actually performed better than the baseline. So the overall results are still lower than the concatenation-based system, but we saw this nice phenomenon where clearly cohort dropout helps outperform the baseline. And if you want to extrapolate, you could say that actually it made the model learn use context. But I don't want to go that far because I have not that many experiments to prove it.
Mm-hmm. Do you have an intuition of why that is, that this mechanism made it use the context more in the multi-encoder case?
So I would say it's a question of parameter sharing, where in the multi-encoder, the model has no obligation, because it has multi-parameters different from the context and for the current sentence, the incentives to actually train the contextual parameters or the parameters of the contextual encoder are not that high. The model can just do the easiest thing, which is just to learn the sentence level. While if you start dropping words or too many words with different probabilities of the current sentence, the model will be forced, and this is an intuition, hand-wavy stuff, I cannot prove this, but my intuition is that if you start dropping too many words of the current sentence, the model will be forced to start using the context to actually be able to translate. While with the single encoder, because the parameters are trained jointly for the context and for the current sentence, it doesn't make that much a difference because the model will still be able to learn to use the context even when only trained on the current sentence because the parameters are shared, basically.
Okay.
Does that make sense?
Yeah, kind of.
I mean, it's hand-wavy, deep learning. No one knows what's going on.
Any other question? If not, I'll just ask one last one. Have you studied how these changes with the large of the context you use? So for example, if you use more than one sentence or if you use larger contexts, does the information you gain keep increasing? Do you have...
Yeah, this is precisely, I don't know, it's weird, I have no control of the slides, but in one of the slides
I
showed that
you showed it, but it was too fast.
Yeah, sorry. No, because at some point I misaligned the slides with my own thing because I have no control of the slides. But it was like basically after a certain point, like the first previous sentence is very important in terms of information gain, but after that you get diminishing returns on the information you gain from including more context, and that makes kind of sense in my opinion. And also like we also gain a lot more information or like cross-mutual information from including target side than source side, basically. Okay. But to answer your question, yes, like according to CXMI, which again is the metric we propose, it's not the absolute platonic way of context usage. I would say like there's a limited diminishing gains on including more context after the first sentence, after the first previous sentence, basically.
Okay, but it's not because your model loses precision on the older ones?
Yeah, it could be, and this is an important distinction that I like to make. Like this is not an absolute like mutual information estimator. This is a cross-mutual information estimator, which is according to our model. It could be that with a model that's more suited to actually use context, it could be that like CXMI with longer sentences is actually bigger for life. But this is the best way we found at the moment, which is to use models, because estimators of mutual information are not very good, basically. And if you use a model, you can say, okay, according to this model, which is what you use in practice, you don't gain that much from including more sentences, maybe with a different method. But the point is, now we have a way to do that. And if you have a method that supposedly uses longer contexts, measure CXMI with it. That is our proposal.
Okay. And just to finish, if you had several models, how would you evaluate them in terms of how much context they are using?
So this is a tough one. Like my impression with CXMI is that it doesn't provide that much cross-module comparability, because precisely the reason that we say that like the difference in probability estimates might be to other stuff other than context usage. It could be that just the model is more substantive because it was trained to be non-calibrated. So I'll be skeptical of comparing across models. I'll mostly use this to say, okay, this model seems to be using context more than when I use more sentences. And to actually measure across models, I'll use the traditional metrics of either pronoun resolution or lexical cohesion, or, spoiler alert, we're going to publish a paper sometime soon on actually having a benchmark that has like 7 or 8 phenomena besides pronoun resolution and lexical cohesion. So in the future, it will be other metrics, but I will not encourage people to use this to compare cross models. I'll use this as almost a diagnosis tool for their own models and use more interpretable metrics such like contrastive data sets to measure actual comparison between models, basically, with accuracies and stuff like that.
Okay. Okay, thank you, Patrick. And I think we'll end the session. We're already a bit over time. Thank you all for coming. And thanks for having me moderate this.
Okay, let's get started. Good afternoon, everyone. My name is João Paulo Cunha. I'm one of the scientific directors of the, okay, we are not yet on the web. Okay, now we can start. Now we are on air. Okay, as I was, well, welcome everyone to this section of the session of the doctoral program of the Carnegie Mellon Portugal. My name is João Paulo Cunha. I'm one of the scientific directors of the program. I've been involved with the program since the very beginning, 2007, as lecturer first and then as PI of 2 projects. It's a pleasure to be here and to see some of our young minds presenting their work. We will have a session more on biomedical themes today with 4 presentations. Our students will talk a little bit about AI-related issues and also about bioelectronics, which is a very close to the heart theme for me. So without further ado, let's then start and introduce Helena Almeida. So Helena Almeida will give us a talk on explainability AI.
Thank you for the introduction. Hello everyone, my name is Helena Montenegro. I am a student at FIOP. I am starting now my first year in a doctoral program. The work I will be presenting today was done during a master thesis and in the scope of the TAMI project. So this work, a privacy-preserving framework for case-based explanations in the medical scene, was supervised by Professor Jaime Cardoso and by a Ph.D. student Wilson Silva, who will also be giving a presentation today. So deep learning cannot currently be applied to the medical scene due to a lack of interpretability, which leads to a lack of trust and acceptance of these algorithms in real contexts. And in order to apply them in real contexts, we need to provide explanations that justify their decisions. One way to do this is through case-based interpretability techniques, which consists of obtaining samples from the data that are similar to the example that we are analyzing to provide as an explanation. However, when we're dealing with medical data, which contains sensitive information about patients, and using this information as explanations threatens the privacy of such patients. So we need to anonymize these explanations before providing them to explanation consumers. So the goal of this project was to develop this ID washer system, an anonymization model that, for medical images that preserves the 3 fundamental requirements of case-based explanations: visual privacy, explanatory evidence, and realism. The existence of such a model would enable the application of deep learning to real contexts in order to aid medical specialists when facing ambiguous diagnostic cases and to make the diagnostic process more transparent to patients. So in order to develop this model, we started by analyzing the literature in regards to visual anonymization methods. And so we compared traditional methods, blurring and case-same select, which consists of averaging the most similar images to the one we are analyzing, and that belong to the same class, and the deep learning method PPRL vegan, which anonymizes through identity replacement. So this network is, again, it has a generator that, based on the original image, generates the anonymized image, which contains as identity the identity provided as replacement identity. And to train this generator, we use a multitask discriminator that contains a real-fake classifier to promote realism in the images, an identity classifier to guide this identity replacement process, and a task-related classifier to preserve the utility of the images. So we apply these methods to a data set of ERIs images for glaucoma recognition, and we verify that none of the methods are sufficiently developed to be applied to our domain of medical case-based explanations. One of the most significant weaknesses of not only these methods, but all methods in the literature, is that none of them explicitly preserves the explanatory evidence of the original image. And furthermore, some methods also possess some restrictions in terms of privacy, like the PPRL vegan anonymizes through identity replacement, which threatens the privacy of the patient used as a replacement. So in order to fix these limitations, we developed our own privacy-preserving model using PPRL vegan as a base and implementing incremental changes in order to adapt it to our intended domain. First of all, we fixed its privacy restrictions by removing the replacement identity and making it so that a multi-class identity recognition network cannot identify any patient from the dataset in the anonymized images. And to do that, we approximate a uniform identity distribution in the anonymized image. We also improve the network in terms of realism, and we explicitly preserve explanatory evidence of the original image by extracting these medical features from the image using interpretability saliency maps and then reconstructing them in the privatized image. And after this experimental process, we obtained a model that is capable of anonymizing while preserving privacy for every patient in the dataset and by explicitly preserving the explanatory evidence. However, the images generated by this method are not very realistic. They possess a lot of noise, and the domain of application of this network is restricted since we are using a multi-class identity recognition network, which is difficult to train in domains where there are few images per patient, which is very common in medical data. In order to fix this problem, we developed a second privacy-preserving model where we replace our multi-class identity recognition network by a Siamese network. So what the Siamese network does is it compares two images and computes an identity-related distance between them, from which we can discover whether or not these two images belong to the same person. So with this network, we increase the distance between the anonymized image and images from the data during training. And with this network, we were capable of obtaining a privacy-preserving method that is capable of preserving privacy for every patient in the data. And we also verify that the realism of the images improves. So this method is capable of fixing two of the weaknesses of the previous method. And so, with our two methods developed, we decided to apply them for the generation of privacy-preserving counterfactual explanations. So a counterfactual explanation explains the decision by showing what changes should occur in an image so that its prediction changes. And so we used our previous architecture and added a counterfactual module, which is a counterfactuals decoder, which generates our counterfactuals by making small changes to the anonymized factuals in order to change their prediction. And with this model, we obtained these counterfactual explanations which show the locations that on the iris that changed from the factuals. To conclude, then, we developed two privacy-preserving models and applied them to the generation of counterfactual explanations. Our privacy-preserving models possess some novelties in comparison with the works from the literature, with the most significant novelty being its capacity to explicitly preserve explanatory evidence. Going forward with this project, we intend to use causality to improve the anonymization method by ensuring that the features, the explanatory features that we are preserving in the images are causally related to a pathology, and in the counterfactual generation process by ensuring that the features we are modifying are also related to a pathology. And we also intend to consider privacy intrinsically to the image retrieval process instead of in the post hoc manner that we have considered so far, where we already had the explanations and only had to anonymize them. To conclude, these are a few of our scientific contributions. One of them has already been published. I just wanted to note that the last one is a survey on case-based interpretability and visual privacy, and it was a collaboration between us and some professors at CMU, so, namely Professor Asim Smilagic and Professor Matt Fredrickson, and we also could count with the collaboration of a PhD student who will be giving a presentation in a few minutes, Alex Gaudio. With this, I conclude this presentation. Thank you very much. Do you have any questions?
Thank you, Elena, for keeping the time. So it's open for questions from the audience. I can start warming up. Can you give us an idea of what is the data set you are using or you intend to use? And how dependable is it from your interaction or future interaction with the doctors?
Okay, so currently we are using a data set that is both medical and biometric, which facilitates identity recognition, which is the data set of ERIs for glaucoma recognition. Okay. In the future, the group is working with images for breast cancer and for images of the X-rays.
X-rays. What is the size? So one issue, as you know, is the size of the data sets that you have access.
Right.
So what are the sizes that you are going to use? And apparently they already don't, depend on, so the second part of my question was how it is dependent from the doctor interaction or your interaction with the doctor, so apparently it's already there. But the size is a very important issue here.
Right. Currently, the size is around 1,000 pictures. It's not very large. I still don't know what are the sizes of our future.
So we're still starting our. Okay. Further questions, please.
So you were mentioning that usually there are only a few images per patient. Can you give us some idea how this can be somehow, how can you deal with this? Is there any expectation that in the future you have more images, or what kind of solution do you have for this?
No, when we're dealing with medical data that is X-rays, you cannot take multiple X-rays of a person without damaging their health. So no, though, our second privacy-preserving model, what it does is use a Siamese network. And by comparing two images and checking if they belong to the same person, we only have two classes, whether two people belong to the same person, two images belong to the same person or not. And so we have much more images, much more of a ground truth, which we can use to counter this problem. Thank you.
More questions? On the back. We're still on time.
Hi. Who is supposed to be the end user of this product, so of the explanations? Do you want to show the explanations to doctors or the patients? Who's the end user? I'm going to call it the end user.
There are multiple end users. We intend to show them to medical specialists, to aid medical diagnosis, and also to patients, to family members. And there is a wide range of users, both that have access to the original data, and so they don't need anonymized explanations. For example, doctors may not need them. But on the other hand, you have patients and family members and medical specialists from other hospitals or that do not have access to the data and therefore need anonymized explanations. Thank you.
Wilson?
So I don't exactly have any question, but just regarding João Paulo Cunha's question. So one of the data sets that we are thinking about using is like a large chest X-ray data set. So there are some publicly available data sets like Shexpert or Mimic that have like thousands of images. And then the collaboration with the clinicians would be more on the for instance, Elena talked about the like factual and counterfactual explanations. So like how do you check that the counterfactual explanation is meaningful? So and like for that you need the input of the clinician. If it really changes the class or if it's just like an adversarial attack.
Yeah. Great, thank you, Wilson. So I must make a disclosure. So I'm also from University of Porto and in ESCTech. So and the first 3 presentations are all from my university. So so I'll try to be as neutral as possible. Thank you, Elena. So let's move to the next presenter. So the next presenter is Teresa Araújo. So she will present us the theme of diabetic retinopathy grading in colored eye fundus images. I think she's online, right? Because she's in, I believe in Austria. Yeah. So there you are. Okay, go on, Teresa. 10 minutes, okay?
Sure.
Thank you.
I'm still not seeing the presentation.
Can you put the image on this screen because it's only there and I have it on the back. Thank you.
And so it's not. I'm not supposed to see the presentation in the link because I'm only seeing my face, but I cannot see the.
Okay, let's see if they can solve it for you.
Yeah, I'm trying, but it only appears shut. There's not the option for pinning it, so it stays very small. Not enough for me to be able to see the text and present through that. Mm-hmm. And as the YouTube link is not live entirely, it's with a bit of delay. Yeah, now it's okay.
Great.
Yeah. So thank you all for attending the session and during my work. What I will be presenting is my PhD thesis, which I defended a few months ago, and it was supervised by Professor Aurélio Campilho and Ana Maria Mendonça from PhilP. And it was framed on the CMU Portugal Research Project Screen the. So the main focus of my thesis was grading color eye fundus images in terms of their severity of diabetic retinopathy, which is a disease that's very common among diabetic people. So just a very short introduction to start with. So this diabetic retinopathy is a complication of diabetes and is one of the leading causes of blindness among the world. So in 2030, it's expected that around 500 million people have diabetic retinopathy. And it's a progressive disease which causes damage to the blood vessels. Actually, this number is the prevalence of diabetes, not diabetic retinopathy, but a large number of these diabetic people are expected to develop some kind of retinopathy. And this diagnosis is based on the images as the one we see on the right, which are color eye fundus images. And usually doctors check these images for signs of the disease, which are several types of lesions, from red to white lesions. And regular checkups are very important because if this diagnosis is made early, adequate treatment can be provided and thus the visual loss can be prevented. So the first and main method we developed was an automatic machine learning, deep learning based approach for predicting this grade in an automatic fashion. And besides predicting the grade, also providing an uncertainty and an explanation of the decision. And the classes or the severity grades we consider are 5, the healthy, and these 4 grades we have here. So we go from mild, non-proliferative DR to moderate, severe, and finally proliferative DR, which is the most severe case, in which the most severe lesions appear in our vessels. And what we do is we designed a deep learning network, which besides predicting, as I said, the grade of the image, also produces an uncertainty U and a lesion map that highlights the regions that were important for diagnosis, so that the doctor can also see the reason behind the decision. So it follows a multiple instance learning approach. So if a lesion from a given grade appears in that lesion map, then the grade of the image is equal to the most severe lesion in the map. So you can take the maximum of the lesion values, and we have the grade of the image. And as I said, besides this map, we also produce an uncertainty, which is learned during the training, and it comes directly from the variance of a Gaussian distribution. So we assume the output follows a Gaussian distribution, and then the variance of this distribution accounts for the uncertainty of our prediction. The larger the variance, the larger the uncertainty, and as we are less sure of the diagnosis we are making. The results we obtain were in line with the state of the art. This is a quadratic weighted kappa, which measures the agreement between two annotators or an annotator and an algorithm, and it has an account in a quadratic fashion. So the farthest we are from the truth in this case, the lower these values. So we have values that are in line with the state of the art, and we also show here the confusion matrices, which should be as diagonal as possible. It means that we are close to the true grade, and this is the case, and being that the worst performing case for us is the R4 or the PDR, and this comes directly from the lack of quality of the training sets we used, which are not labeled as well as they should, and so we end up predicting other signs than the neo vessels as the true reason for the PDR. And this is analysis of the uncertainty, because we want in the end that our uncertainty is a good measure of the quality of the prediction, because if it is, we are able to, based on that uncertainty, select the cases that should be or are more preeminent to be reviewed by a specialist. And indeed, we see that for higher uncertainties, the quality of our prediction decreases. So it means that indeed, uncertainty appears to be a good quality of the prediction of the network. And thus the model could be used cooperatively in the clinical to indicate ophthalmologists which could be the cases that are more important to be reviewed first. Also, we find out that our uncertainty estimation is tightly related with image quality, and indeed images that present much blur and light artifacts are not as gradable as the others, so it may be that they are not gradable at all. And thus, the fact that our algorithm predicts higher uncertainties for those bad quality images is nice. And also, we made predictions on different images, not retinal images, and we found out that the uncertainties are in generally higher for these out of distribution images. So it is also not completely capable, but indicates that it has some ability to do some outlier detection. And the explanation maps also appear to highlight regions that are interesting for the diagnosis. So we compared our explanation maps with notations from the ophthalmologists, and most of the regions fall in places in which the doctors annotated lesions. And the major problem is indeed the neo-vessel detection, as you can see in the image from the left bottom, in which it misses to detect the annotated neo-vessels, which are not recognized as being a sign of PDR. To try to address this, we developed an heuristic-based model for augmenting data sets for training. So we artificially introduce neovessels in the images in order to help the algorithm learn these patterns and then be able to detect these in true images, in true R4 images. And we do this based on the optic disc and vessel segmentation of retinal images. We account for the position of these structures and also for their color in order to do an introduction that is as it looks as realistic as possible, because in the end we want these vessels to resemble true vessels. What we do for generating these vessel structures is similar to how a tree grows. So we start in a point and then progressively add new points, new branches. And this growing algorithm is based on a set of parameters, being the most important, the number of branches that will rise from a point, the angular range in which they may grow, the number of points between two branching of springs, and also the distance between subsequent points. So in the end, we have a structure like a tree, and we define a set of different shapes that we allow the vessels to have based on prior knowledge from what we see on real images. And these are examples of images that originally did not have neo vessels, and now they have our creative artificially neo vessels, and they seem quite realistic. And now then we use these images to train an algorithm and see how it behaves on true R4 images, which are these cases. So in here we have examples on the left, on the first column, images that were originally not being detected as R4 by our algorithm. So it was not able to find neo vessels. And then, and then in the middle cases of, and then in the middle, the new maps after the network being trained with augmented data set, and we see that it's now able to detect these neo vessels which were missing before. And then just a small finishing note. So we compared our final algorithm with the performance of ophthalmologists from our project, from ScreenDR, and the method appears to be performing quite well. This is having an ophthalmologist as reference and comparing 3 other ophthalmologists, which are each of these points we see here, and our algorithm, which is the orange curve, and you see that we are mostly in line with the performance of the ophthalmologist, which is nice. And the performance is particularly good, as you see on the right, for the detection on referable DR detection. Referable is R2 or above. And indeed, we have a F1 score, which is actually better than that of the, in line with that of the specialists, and have a specificity or a recall, which is actually better than the specialists. And this is nice to have in a screening mode, because we are able to detect most of the positive cases and be able to refer this to further analysis by the doctors. That's it.
Okay.
Thank you very much.
Thank you. Thank you. So it's open for questions. Ines?
Hello. Okay, when you had the generative tree for vessels, for vasculature, how once you define a tree, how does that create a vessel that looks realistic? I missed that part.
Yeah, we experimented, and it was like we started at a given point and then define a set of parameters for the angle, for the distance, and for etc., which defines in which direction and how much a given branch will grow. And then we define stopping criteria. So in the end, we have to have a stopping point so that the tree does not grow indefinitely. But then, according to the shape we define, which maybe is more of a circular shape or more like a broom shape, so the growth goes according to those parameters. It's random, but in the ranges that we defined.
And how do you colorize it?
The color, yeah, it was very briefly, just I did not refer that part. The color comes from the color of the vasculature that's in the neighborhood region that we defined. So we take into account the background and the color of the vessels in the insertion point. And it depends on if it is in the optic disc or if it is outside, because the visual appearance of the vessels inside and outside optic disc quite varies. But it's based on mostly on the background and on the vessels of near the insertion point.
Okay.
But in the paper, I
Let's
define
take a question from the audience now.
Okay, thank you for your presentation, Teresa.
Thank you.
I have one question. At some point in your presentation, maybe I missed something. You talked about explainability. So in the context of your work, what kind of explanations would you get?
Is that the lesion maps I showed? So it's the image of the eye with the regions responsible for each of the grades highlighted. So it's like, in this case, I showed as curves surrounding the regions that the algorithm found as being responsible for a given grade. So it's a visual map.
Right? More questions? Still have time. I have my own question, so I will use it now. So, as I understood, and probably you were presenting the results of that, but I would like to know a little bit about it, which is you, in your work, you used artificial generated images to improve the screening algorithm, right? So it was not very clear how was the improvement in comparison to the initial algorithm of screening. Of course, you showed comparison to of course, the ground truth, which would be the labeling of the doctors. But what was the difference to the initial algorithm before you had the artificial generated images?
Yeah, the increase in our private data set was actually significant. I mean, we don't have many examples of these images in real life because the most severe cases are actually not very common, which is good for the patients, but it's bad for the algorithms. So we don't have many examples to test that, but it improved in our private data set. In the data set that's similar to one in which we trained, as there are images which are not labeled based on the criteria they should have been labeled, we don't have lesion ground truth to be able to directly compare that. So it improved, but it not improved at the level we would expect it, would like to improve, yeah.
Understood. Great. Any more questions? Okay, thank you, Teresa. Let's move to the next presenter. So the next presenter is Alex Gaudio. He will talk to us about understanding and exploiting redundancy in deep networks with application to XR.
Great. Hello, everybody. Thank you. Thank you for the opportunity to present today. And thank you, everybody, for being here. Are my slides up? Because I can't see them.
Now okay.
Okay, great. So today I'm talking about recent ongoing work, explain fixed, explainable, spatially fixed deep networks. Okay. I think if we talk about machine learning at all today, especially, very often the algorithms we talk about are using deep learning and deep networks in particular. And I think we all can kind of notice that deep networks are surpassing human performance in many areas. In the biomedical image analysis field, for X-ray example, the Chexpert dataset shows that 2 out of 3 radiologists are outperformed at least by state-of-art algorithms, and similar results hold for cervical cancer and glaucoma. And in literally all areas, we are seeing this trend. okay? But the performance we're getting comes at an unreasonable cost. And there are increasing numbers of works that are pointing this out, but the field of deep learning as a whole is unsustainable. And I like this picture, this plot from a recent paper out of MIT that compares the compute needs of deep learning to the current rate of hardware, the current performance enabled by hardware. And you can see the red line, the deep learning line, is shooting through the roof. And this is problematic for many reasons, but in particular, it's unsustainable. And it's getting to the point now where even Stanford University in California, in the United States, has created a new center dedicated to what they're calling foundation models, huge models that are so big that people can't use them. It's not democratized, and the data sets are very large. And just even simple models that use like MobileNet in the table on the left uses millions of parameters. So it's, this is one problem that I observe, and the solution should be simple. We should just make deep networks more efficient. Another problem that we have, and hence the need for explainability, is that the deep networks are still largely a black box. And here's a paper that said that the decisions of deep networks are poorly understood. Right? And so the takeaway here is that we need different kinds of explanations. And I think we can break this camp into three main groups. One would be explanations of the models themselves, the deep networks. The second kind of explanation would be an explanation of the predictions or the output of the model. And the third would be the explanation of the data, which is something we've been doing for a very long time in general. So if we take kind of both of these big problems in mind, the efficiency problem and the lack of explainability problem, I think in the field of deep learning, we need to have a paradigm change. We need to have a paradigm change. And my goals are the following towards this paradigm change. We can show or create that deep networks can be used to have matching performance, matching predictive performance with minimal or no learning. We don't need to learn them. That's one of my goals. The second is to significantly improve the efficiency of the networks, to democratize them, right, and make them smaller and more usable. And then third, kind of as a consequence of trying to do these, we naturally uncover explanations of, particularly of the models themselves. Not necessarily the explanations of the predictions, not necessarily explanations of the data, but explanations of the models. And so what I'm going to present today is some recent work, ongoing work, the explain fix. And the design principles of this are the following. First, that we can fix and not learn the convolution filters, the spatial convolution weights of convolutional neural networks. And the second is that even if they're fixed, we don't need almost all of them. We only need a very small percentage of them. Okay, and so the way we have gone about doing this is to first create some model-based explanations of deep networks, and specifically of the spatial convolutions in deep networks, to understand the concept of steerability in the convolution and exploit the idea of saliency in convolutions. And then as a result of these explanations, here's an example explanation on the bottom left, where we can see that in this analyzed deep network, we're visualizing what we see, and we can see that towards the left, the x-axis shows the layers of the network, and the y-axis shows the frequencies that are more relevant in the different layers of this model, the different spatial layers of this model. And we can see that early frequencies and early layers are important, and the rest are basically unnecessary. And so as a result of this explanation, we can generate all sorts of speed and accuracy gains on the models by removing almost all of the filters and getting the same performance. So here we have a horizontal line showing no change in performance, in predictive performance, but the model being significantly more sparse. Not smaller in RAM, but more sparse in this example. And I'll show later that we can also improve the accuracy in some cases. And as a consequence of this, we're open sourcing a set of tools for pruning, for generating new spatial filter initializations, and this explanation method. Okay. So here are the first two results from the previous page. And you can see here in the bottom, there are some other kind of simplified results for this presentation, where what we did was we took these represent two experiments that show basically that we can remove nearly all of the weights from deep networks, not just by zeroing them out, but literally removing them and removing all of the neighboring nodes. And in doing that, the performance stays about the same, but the model is far smaller and evaluates far more quickly. Okay. Next, and then here we show on the top left that by fixing the spatial weights with different initialization methods, we can get performance that's even better. Fixing not learning weights gives performance that's even better than a fully learned deep network. And this is kind of a shocking fact. You can just take, it's a very cool fact. You can take all of the spatial convolution filters in deep networks, fix them, don't learn them at all, and the performance that they give you outperforms a fully learned network. Moreover, this holds not just for smaller models, but it holds for models of increasing size as well. And it holds on different data sets, two different data sets, microscopy and X-ray data.
2 minutes, okay?
Okay, thank you. And then on the right here, it exposes the idea that the convolutions by design are steerable. And so one of the explanations of this work was to show that convolutions should be initialized with a steered representation. And if they're not, they'll learn the steered representation if they're learned. Okay. So in conclusion, we should fix and never learn all spatial filters because it gives us efficiency gains without loss in performance. Remove all the filters and make smaller models. And so we've contributed some explanations, speed and efficiency gains, and novel tools. Okay. There are several other directions that I'm going now towards this goal of fixed filter networks. I'm trying to make completely fixed networks that have all weights not learned. And there are many different kinds of directions and applications of this that I'm currently exploring. I'm happy to answer questions about it, if there are any. Thank you.
Okay, thank you very much. So we will take questions from the audience. Jose? So we are going to get a question from the boss.
Very interesting work. There is so this issue of reducing, throwing away weight and all this, trying to learn smaller models. There is some recent work, I don't know if you are aware of, where they say, okay, let's start with, I don't know, a very dense network, and then randomly initialize the weights. And what you do is to learn how to throw away which connections and get a reduced model with the random original weights, but much fewer connections. Maybe you set the threshold, maybe I will only keep 50%, 30%, 60%, whatever number. I don't know if you have any hints or insights into these types of architectures. Thank you.
Thanks. That's a great question. So I'll start my response to that by saying when I started this project, I had no idea that I would be focusing so heavily on pruning of deep networks. It was the explanations that led me to the fact that they're very inefficient. And in the pruning literature that I have read, there is some work that has focused on removing connections in different kinds of ways. The solution that I have come to in this work was one based on saliency. So I took basically the idea of smoothgrad, which is a saliency and explanation method for generating saliency maps with respect to the input. And I applied that to the saliency of the weights and used that as a way of kind of giving an importance over all of the neurons in the network. And then based on this importance score, you can just remove the least salient neurons. And in context of the experiments, I was focusing exclusively on spatial filters, the spatial convolution kernels, which I don't think anyone has focused on so specifically before. So that's the scope of my work. But yes, I hope I answered your question.
Thank you. Good. Further questions from the audience? I'll use my question, which is, you showed some examples, of course, and you showed beautifully, how they were, early spatial layers were mattering most to the learning, and the low frequencies would diminish. But you showed examples, right? So my question is, how general is this? So what are you thinking to do to, to prove it or to show that this type of behavior that you encounter is more generic than the examples that you are using?
So that's a great question. So I ran this on 3 different common architectures, 3 different kinds of deep network architecture. Actually, I'm sorry, 4 different architectures and 2 different medical image data sets. The big caveat with this work is that the 2 data sets I used, one is small, one is large, one is semantic segmentation, one is classification, but it's only 2 of them, and both of them deal with black and white images.
Good. So you have a lot to search because it may be a local minima, right?
It could
be.
A
local effect, right?
It could be. It could, yes.
Great.
But
So
been exploring this art elsewhere, and it still seems to hold. So we'll see.
Great, thank you. Any more questions? Great, thank you, Alex. So let's move to the next presenter. Sorry, I was looking at another document. Okay, next presenter is Manuel Carneiro. So he will talk to us about stretchable multi-electrode bioelectronics and the future of healthcare. So this is a completely different theme, finally, and not only AI. Go on.
So I'll focus more on hardware than software. And it's a pleasure to be here today and having the opportunity to talk to you about the impact that stretchable and wearable electronics can have in improving healthcare. And I wasn't able to find a better example of the struggles of healthcare systems than with the current COVID-19 pandemic. And as you see, during the peak of this pandemic, hospitalizations peaked all over the world, and due to limited beds and limited human resources, it wasn't possible to deliver the best care and treatment to everyone. Yet, with the advent of health monitoring wearables and real-time biomonitoring, this data can be remotely collected and analyzed, and warnings, for instance, can be automatically sent to an emergency service or the healthcare provider of the patient. So, by creating for instance, a wearable that measures heart rate, respiration rate, temperature, movement, and blood oxygenation of the patient. We can create a system that enables domiciliary hospitalization. So this is the main goal of the WOW project, one of the 2020 CMU Portugal large-scale collaborative projects. Yet, with recent technological advances of wearable electronics and stretchable systems, we are not limited to simple signals, such as heart rate or temperature, and we can go as far as measuring brain activity with a relatively simple setup. And this CEG acquisition headband is my main focus today, since it's such a great example of how stretchable and wearable electronics simplify medical procedures and simplify the lives of the patients who need them, without affecting the quality of medical exams. So that we are on the same page, EEG stands for electroencephalography, and it's basically the monitoring of the electrical activity originating from the brain. And it's usually done by placing metallic electrodes on the patient's skull. The acquired signals tend to be very low intensity and are quite prone to noise. And apart from medical diagnosis, for instance, to diagnose epilepsy, EEGs can be used for patients with cerebral palsy or spinal cord injuries to control wheelchairs or other devices that allow them to have more independence in their daily life. And although this technology exists and is quite mature already, there are still some drawbacks in the available EEG hardware systems, so that few people are able to take advantage of this technology daily. So current EEG systems are quite bulky, they have a lot of wires, the rigid electrodes can become uncomfortable after long periods. Also, the setup of this system is quite time consuming and an expert technician is also needed. And finally, they are so unattractive and they are not practical for daily usage. And around 70 million people worldwide could benefit from a plug-and-play, low-cost and comfortable system. And that's why we developed this modular wearable EEG system. It is extremely low-cost, easily customizable to the user needs, and can be set up in less than 1 minute by anyone, by any experienced user. So using conductive ink developed in our lab, we were able to print high-quality electrodes directly on the textile substrate. And apart from the electrodes, the textile system includes all the electronics that are needed for amplification and processing of the signal, as well as wireless transmission of the data. The biggest advancement of this work is the fact that we can integrate multiple electrodes, virtually as many as we need, in a modular textile system that can easily be set up by anyone in a matter of seconds. As well, these electrodes can be printed in positions that are specific to the patient wearing them and to the medical issue that it's trying to be detected. The fact that our conductive ink is also flexible and stretchable allows the electrodes to adapt in a comfortable way to the human skin, which doesn't happen in other state-of-the-art EEG systems that use rigid metallic electrodes. The high comfort and portability of this system open doors to, for instance, monitor a patient suffering from epilepsy in their daily life to predict possible seizures before they happen. So we were able to show that the signal quality of the system is better than the one of rigid electrodes, with the advantage of the system being reusable for several times without happening signal degradation. So the characteristics of the system include the low cost, comfort, reusability, the fast setup time, as well as the modularity, making it ideal to be used in, for instance, emergency rooms, human-machine interfaces, as well as remote health and domiciliary hospitalization scenarios. So to showcase the applications, we created a very simple human-computer interface that detects eye movement, and it can easily be adapted to control a computer mouse or wheelchair. As well, this wearable was also tested for sleep monitoring and proved to be quite effective for sleep staging studies. It is also very comfortable and it won't affect your sleep. Wrapping up now, trying to shift the healthcare system with user-friendly wearables is not a one-man's job. So I must thank my advisors, Professor Mahmoud Tavakoli from the University of Coimbra and Professor Karmel Majidi from the Carnegie Mellon University. And I also have to thank CMU Portugal for this opportunity, as well as all the partners that contribute to this research.
We have some few more minutes for questions for you. So questions from the audience, please. I can start because I have a lot of them. Oh, there's one there. Then the primacy is from the audience, not from the moderator.
Hi. So it looks, I don't know much about neuroscience, but it looks that you're monitoring a much smaller part of the brain. Is that not relevant?
Yes, it is relevant, and this is because of an issue that most of us have, which is hair.
Yeah.
Yeah, it's quite difficult to secure these flexible patches in airy surfaces. And it's as well quite difficult to monitor EEG in airy areas with these ultra-thin electrodes that don't penetrate inside the hair. We are trying to solve this through 3D printed soft electrodes that enable the penetration through the hair, but it's still an ongoing work. So we are for now focusing on the forehead.
But are you getting different results by monitoring the forehead and not the full head?
India.
That's a question.
He was not hearing you.
Sorry?
Can you hear me?
Now I can, yeah.
Yeah, so I was asking if you can, if you're getting different results because you're monitoring just the forehead and not the full head. Do you get different results?
So we can't get as much data as when monitoring the full head. Yet for most human-computer interfaces and as well sleep staging, as I showed, it's enough. So we can work with that for most applications, yes.
More questions, please.
Is there any importance to the placement of electrodes on your forehead? And why can't people use antennas or something?
So the placement of the electrodes will affect the signals that we are getting. For instance, electrodes closer to the eyes will get much more muscle artifacts from eye movement, for instance. And that will affect, of course, the output of our system.
Okay, thank you. More questions? I'll use mine now. So one of the very difficulties that you get when you are doing, well, in this case, it's a snap-to-skin version, so you are putting electrodes over the skin, is motion artifact robustness. And even being flexible, that means that it's more motion prone. So how are you coping with this? Because that's typical something that we tried to do for ECG 15 years ago, and it was the hardest challenge was to use, something that is, stretchable, but at the same time has good quality under motion.
So most motion artifacts arise from long wires, from unattached wires, as well as from movement between the interface, the electrode-skin interface.
And vibration. Vibration, if you put someone walking, then it's gone, right?
Yes. Yes, because there is this movement in the interface, in the skin electrode interface. Yeah. Since we are securing such ultra-thin electrodes that conform to the skin, that conform and adapt to the body, we can reduce these artifacts. And we also don't have any hanging wires or so. So the artifacts are much reduced. Still they happen, yes. and they are difficult to cope with.
Great. I would like to see results on that in detail, because in our presentation there was no, a lot of promises, but no deep results on how to address these difficult problems. And there are some others, but we have no time to go through that because my watch is already telling me that we are over time. Okay, thank you very much. Thank you very much for our presentation. It's a very nice work, but I would like to discuss some details of it in the future. Okay? So thank all the presenters, and thanks also to all the people that were present on this session. And I think I can now close. I guess this was the last presenter, right? Yeah. Thank you very much.
Friends at home, we'll have a 2-minute break while we change panelists here in the room. Thank you.
Okay, so welcome to the last session, everyone. My name is João Abreu. I work at OutSystems. I've been invited here because I'm involved in one of the large-scale collaborative projects. So today we're going to have 4 very different projects in terms of approach and in terms of the specific goal that they're trying to solve. But there is, in my opinion, a very common assumption behind all of these projects. And that assumption is that digital systems are becoming too complex. And we need somehow help to manage those systems. And I'm not talking about the user experience of the people who are using those systems. I'm talking about the people who are engineering, creating those systems, monitoring those systems, making sure that those systems do what we want them to do. So what we're going to look at are 4 different approaches. Some are about actually programming for us automatically. Others are about verifying that the programs do what we want them to do. But in a sense, they all kind of try to solve this same global problem of complexity in engineering digital systems. So the first person who's going to speak is Ricardo Brancas. Ricardo is a student of IST, Instituto Superior Técnico, and Ricardo is worried about data querying, and he's trying to make sure that people who don't necessarily know about SQL, which is the language that's the standard language for doing querying can also do data querying. Ricardo is supervised by Vasco Manquinho from Instituto Superior Técnico and by Ruben Martins. And his project is called Cubes, a new dimension in query synthesis from examples. Ricardo, do you want to show us what you're doing?
Hello everyone, my name is Ricardo, and today I'm going to talk to you about my work, Cubes, a new dimension in query synthesis from examples. This work was developed in collaboration with Técnico Lisboa, INESC-ID, OutSystems, Carnegie Mellon Portugal, and FCT. So, I'm going to start by explaining what program synthesis is and how it works. Next up, I'm going to give a brief overview of the sequential part of our tool, so Cubes. Then I'm going to present the parallel part of our tool, how we take advantage of parallelism to improve the performance. And finally, I'll show you some results and present a quick demo. So starting with program synthesis, what is it? So imagine that some user has a database composed of 2 tables that I show here on the left, so the courses table and the grades table. And you wish he had some query that would turn those 2 tables into another table that I show on the right, the expected table. In this case, the query is very simple, so it simply counts how many grades there are in each course, but the user doesn't know SQL, so he can't write it. So in practice, the user wants to obtain something like this. He simply wants to select the course name and count the grades, etc. So this is the job of a program synthesizer. We have some specification that can be of many types. In our case, it is input-output examples, so the 2 input data tables and the output table. And we want to produce a program that satisfies that specification. In our specific case, a table manipulation program. So this is what program synthesis is, very briefly. So how does Cubes work in particular, the sequential part? So this is a simple diagram of Cubes. Like I said, in the start we have the specification, which is an input-output example on the left. And on the right, we have what we wish to obtain, which is a program that satisfies that specification. Cubes provides the solution in 2 forms, as an R program and as a SQL query, which are equivalent. So looking inside the program synthesizer, starting in the program enumerator, the job of this module is to continuously generate new programs called candidate programs. Now, these programs might, of course, satisfy the specification or not, and that is the job of the program verifier. Check if the candidate program satisfies the specification. If it does, then we find a solution and we can return it to the user. If it doesn't, then we need to try again until we find the solution. So this is a brief overview of the sequential part of Cubes. Now, why did we have this idea of trying to make a parallel program synthesizer, which is somewhat of a novel idea? Where it started on is that, as you might know nowadays, CPU manufacturing companies are not able to increase the frequency of processors anymore. So it's no longer feasible to just wait for the next generation of processors in order to obtain improvements in performance. And so our goal is to take advantage of new processors that are coming out, which focus in many and more cores. So that was our goal. So to do that, we need to find a way to parallelize this problem. So we start with the program space, which is simply the set of all programs that are ever considered by cubes. So all programs that can ever be a solution. And what we do is we divide this program space in many small partitions. So this is an approach called divide and conquer. Now, as I said before, we use many partitions, which we call cubes. And we have many more partitions than we have available processes. So what we do is we start with the more likely cubes, the ones we think we will find a solution in, and we distribute those cubes among the processes. And then for each cube, there are two possibilities. Either there is a solution in that cube, in which case we find it and return it to the user, or there isn't. And in that case, when we run out of programs in that little partition of the program space, we discard it and we move on to the next one. We do this until we identify the solution or we run out of time. So we need to have a time limit because the space of all programs is infinite. We can just keep adding lines over and over again and generating new programs. Just to give you a brief idea of what a partition of the program space means, this is an example of a cube. And in particular, this cube contains all programs that have two lines, and where the first line is a filter operation and the second line is a summarize operation. So this is how we define cubes. Here I have some very quick examples just to give you an idea of the programs that are contained in this partition. So for example, the first program has a filter of the grades table, course ID, etc. So very simple. So this is our approach, and now I'm going to show you some results to see how this compares to previous work in SQL synthesis. So overall, we use around 4,000 instances collected from different sources. Some are from previous work in SQL synthesis from examples, and some are from SQL synthesis from natural language processing, which we adapted to the problem of example-based program synthesis. So in this plot, in the x-axis we have time. The time ends at 600 seconds, which is 10 minutes, which is the time limit that we set. And in the y-axis, we have the percentage of instances solved. Each line in this tool represents each line in this graph represents a different tool. So the first three lines, site, squares, and PathSQL, are previous work on program synthesis. And then we have cubes sequential and cubes divide and conquer, which are our approaches. So just to give a very quick explanation of how to read this graph, if you look, for example, at the 10-second mark and at the squares line, we can see that it matches at around 25% instances solved. And what this means is simply that 25% of instances can be solved in under 10 seconds if you are using squares. So some key points from our results. If you look at the pink line, which represents the sequential version of cubes, we can see that it solves around 3 times as many instances as squares, which is the tool that we base cubes on. And we accomplish this by supporting more programs. So we increase the program space, so we are now able to solve more instances. We use better solver options, which provide a great improvement to our performance. And we introduce several pruning techniques, which allows us to automatically discard programs that we know will not lead to a solution. Moving on to the parallel version, so the green line at the top, we can see that splitting the program space in cubes allows us to search more relevant areas of the program space first. And so we are able to provide more solutions more quickly to the user. And we are also able to solve 9% more instances overall when compared to the sequential version. Okay. Looking back at the example I showed in the beginning, So the user had two input tables, the courses table and the grades table, and he wanted to obtain that query, which produced the final table. So I have a quick demo to explain how cubes work. So on the left, we have the specification file. The first three lines specify the two CSV files for the input tables, while the third line specifies the CSV file for the output table. And I present the CSV files on the right. And finally, we also give some extra information to the synthesizer, showing that we want to count something. So we provide the count function as an input too. So we provide this file as an input to cubes, in this case the sequential version, because it's a simple example, so we don't need the whole performance. And cubes provides two solutions, a solution in R and a solution in SQL that both solve the problem. To conclude, we extended the range of supported programs compared to previous tools for SQL synthesis. We introduced new pruning techniques, which allows us to drop programs that we know that won't lead to a solution. And we introduced the first parallel SQL synthesizer. As a median, we obtained 22 times speed up for hard instances. Finally, we performed an extensive analysis, which I showed a small part in this presentation. I'm happy to answer any questions you may have.
Thank you, Ricardo. Does anyone have any question? Yeah, over there.
Thank you, Ricardo. So it is a great work. I was wondering, I don't know like the way you do the synthesis, but my question is, for example, can you do the same in the GPU, for example, so it would be even faster than working on the CPU?
So the way we enumerate programs is using something called an SMT solver, so a logic formula solver. And we do this in order to apply the pruning that I talked about before. So in order to automatically exclude programs that we know that will not meet the solution, we use a logic formula to exclude those problems. There has been some previous work in using these solvers in GPU, but as far as I know, it has been kind of limited and mostly to SAT solvers, I think, although I might be wrong. Someone in the audience correct me if I'm wrong. So I personally do not know of any SMT solver that works in GPUs.
Great talk, really interesting work. Is there anything specific about SQL that, say, prevents your approach to be used in other domains or domain-specific languages?
So the short answer is no. So SQL is actually a little bit harder than most languages because it's a complex domain. So for a single input-output example, there's a lot of data. And in particular, one of the things that makes it harder is that there is no complete logic theory for SQL. So it's a bit harder to do those deductions that allow us to exclude incorrect programs. So if anything else, it would be easier to use this approach for simpler domains.
Any more questions? I'll ask a question. It wasn't very clear for me how you split the problem into what you call cubes for running in parallel. What's the heuristics or?
Okay, so so that's a hard problem. So I think the main question here is when are we getting close to a correct program? And this is difficult because a very tiny change in a program can completely change the output and lead us in the wrong direction. So we have some methods of scoring which are based on the values that appear in the output. So if we have all the values that we want in our expected output in our actual output, then we know we expect that we are getting close. And so the way that we do it is at first we start generating cubes at random, And then if we see that the cubes are generating output similar to what we expect, then we generate cubes similar to the ones we have generated in the past. If not, we try to explore some new different cubes in order to find promising areas of the search space. I don't know if that was exactly your question, or if it was more about how the cubes are generated themselves.
So let me give you a bit of background. We know it's, let me ask you another question which I think relates to that. So is there a way to use the knowledge that we have about real queries that are being done in the real world? Mm-hmm. And we do have access to that, in particular, for example, at OutSystems, and we know what kinds of queries are more common and so on. Are you using, or could you use that kind of information to decide what those cubes are, or to prune the problem space and so on?
Yes, of course, that is a very good idea. Right now, we are using a very simple model. So we are using a big RAM model. So for each pair of two operations, we have a probability, not exactly a probability, but similar to a probability, that indicates how likely it is that, for example, a summarize will appear after a filter. Mm. And that's everything we are using right now, and that's the score that we update as we train the cubes. A different approach would be to either pre-compute those diagrams based on previous queries, which would already be a great improvement, or to replace those scores entirely but by something smarter. So for example, a neural network that for any given sequence of operations would give a likelihood of there being a solution in that cube or not.
Cool. Does anyone have any other questions you want to ask Ricardo? Okay, so thank you very much, Ricardo.
Thank you.
Let's move on to the next project. So, Margarida Ferreira. So, Margarida is also a student of Técnico. And Margarida she'll correct me if I'm wrong, she's worried about congestion control on the internet, and she's trying to reverse engineer the algorithms that are being used for congestion control in order to evaluate and understand how those algorithms work. So Margarida is being supervised by Inês Lins and by Ruben Martins from Carnegie Mellon. Margarida, do you want to go ahead?
Yes, thank you for the introduction. Okay, so do you see everything? Yes. Yes, I'm presenting the project I've been developing as I start my PhD with the CMU Portugal program, and the project is called Counterfeiting Congestion Control Algorithms. Our main goal is, as you said, to reverse engineer congestion control algorithms. I will start by explaining what a CCA is, why we think we need to reverse engineer them, and how we are doing that. So let's start with the definition of CCA. Suppose you want to watch a movie on the internet, for example, on Netflix. First, there needs to be a connection between your laptop and the Netflix server, and then the Netflix server will use that connection to send the movie to you. This is not done all at once. The server will split the movie into little chunks, we'll call them packets, and it will send just a few at a time. The goal of the CCA is figuring out what is the optimal rate at which to send these packets such that you get the movie to you as fast as possible. For this, we have a structure called a congestion window that just tells us how many packets are being sent at once. So if we start with a small congestion window, the packets will arrive at your laptop, and if they are good, the laptop will produce an acknowledgement or an ACK that tells you exactly that. However, if you send just a few packets at a time, it'll take too long for the movie to get to you. So you might want to try to send more packets at once. But then what might happen is that if the connection becomes overloaded, some packets may be lost or delayed. And that's not what you want. So the idea of the CCA is very simple. You start slow, and if the packets arrive fine, then you want to speed up. That means you want a larger window. And if they start getting lost, that means your connection is overloaded, so you start slowing down or decreasing your window. Here's a picture of a commonly used CCA called Reno. In the y-axis, you can see the congestion window size, which is a measure of how fast Reno is sending, and in the x-axis, you can see the time. So in these parts where you see the window increasing, that means that the packets are arriving okay, and so Reno is increasing the sending rate, the window. In here, where the window size drops aggressively, that's because there has been a loss. So Reno knows the connection is overloaded and slows down very fast. While we know Reno, there are new applications on the web that require some CCAs that we don't know of. And some of these CCAs are proprietary, which means we're not able to look at the code that implements them, and we don't know exactly what they are doing. So my goal is to reverse engineer these CCAs. There are certain properties that we always want to ensure that CCAs on the internet have. We want them to be efficient, which means that when there are several devices accessing different servers, we want the data to get to the devices as fast as possible, which just means the connection is being used entirely. Besides efficiency, we want them to be fair. This very simply means that if you have the connection and you're the only device using that connection, then you get 100% of it. But if someone else is using the same connection as you, you want to make sure that both devices get approximately 50% of the bandwidth. And you think, okay, I've been using the internet, I'm sure this is happening, but not really. We know that some companies have deployed CCAs that didn't satisfy these properties. For example, 2 years ago, some CMU researchers found out that Google's CCA is not fair. Some devices accessing Google would take up more bandwidth than their fair share. They were able to know this because the CCA was open source, so they were able to look at the code. Our goal is to reverse engineer the CCAs that we cannot look at the code, so that studies like this can be done on them. Okay, and how are we doing that? More or less using the same technique that Ricardo told you about. We are using program synthesis. The idea behind this is very simple. You have a set of inputs and you have an output, and you know that there is a function that when is given these inputs will produce that output. And the goal of synthesis is to tell you what this F is. So if you grab those input-output examples and feed them to a synthesizer, it will give you the expression that produces them. We want something like this, but not quite. We want given network traces to come up with a CCA. Let me show you why this is different and what a network trace is. Here on the right, you can see an example of the beginning of a trace. It's no more than a timestamped record of what's happening in the network. So you can see what packets have been sent, and you can see what packets have been hacked. So they arrived correctly in the laptop. And you can see that this, while time goes down here, you can see that this is the same as time going right here. When you see the window increasing, that means that acts have been received, and when it drops, that's a loss. And this is slightly different because we want to synthesize the H, that's the congestion control algorithm, and we have the AX and the sent, but we don't have all of the inputs. We don't have the state. So this is a little different from the F that I showed you before because we don't have all of the inputs and we don't have the output. What we do know is that the state that is the output on time step 0 will be used on time step 1 and so on. So each time step will take as input the previous time step's output. So what we want is this H function, then when composed upon itself, will produce a final state that we don't know. and middle states that we also don't know, but somehow they are coherent with these traces that we have. As you can see, there's a lot we don't know. So while in our traditional synthesis, we had the whole input set and we had the outputs, and the synthesizer will just happily give us the expression. For CCA synthesis, we have something a lot more complex. So if you just ask the synthesizer for this, it will be loading forever and it will never give you an answer. And that's not what we want. So we have a prototype synthesizer called Mr. 880 that is focused on finding congestion control algorithms based on traces. This is the overview of our general algorithm. And unfortunately, I don't have the time to show you in full detail what's happening, but feel free to ask me questions afterwards. We just basically start with the shortest trace, and we use just that for the smart part of this synthesizer, which is the solver. And then we use the rest of the traces for the simulation part, which is the fast part of the synthesizer. All the rest of our ideas are applied here in the solver. I will just show you what we can do right now. So Mr. 880 is just a prototype, but it is able to synthesize the CCA that I showed you before, Reno. This is the H functions for Reno. We can synthesize this function and this function. And just so you have an idea, the first approach of just using a traditional synthesizer would run for 1 day and not finish. And with Mr. 880, we were able to come up with Reno in just 13 minutes on an old MacBook. That's not a server with amazing CPU power, it's just an old MacBook. So looking into the future, right now we just have Reno, and we really want to work on real-world CCAs. To do this, there are some challenges that we need to address. First, we need to be able to synthesize from internet traces, real internet traces. Those are a bit more complicated than the ones I have right now, because the ones I have right now are simulator generated. So everything is very clear. And in the internet, it doesn't happen like that. In practice, this means that instead of looking for a CCA that completely matches my traces, I have to look for the CCA that best matches my traces. This is a much harder problem. Second, I want to synthesize more complex CCAs. Reno had operations like sum, division, and multiplication, but I want more. I need to be able to support operations like conditionals and exponentials. This means that my synthesizer will have to look at the larger space of functions to find out the correct one. Even though we will be able to support more complex CCAs, there are some CCAs in the wild that will never be able to synthesize. Some of them use very complicated machine learning algorithms, and we don't think that our synthesizer will ever be able to represent that. In these cases, what we really want is to find a simpler algorithm that yet fits the traces. Because if we find a simpler implementation, this is really interesting. It means they're doing this complicated thing, but there's this simple thing that is easier to study that does the same. So these are our challenges going forward. To summarize, my goal is to have a tool that helps us understand CCAs and make sure the internet is fair and efficient. We have a paper in HotNets 2021, which you can check out if you want more information about our algorithm. And yeah, that's it. I just want to thank my collaborators, Akshay, Inês Lins, Ruben, and Justine. Thank you for listening to me.
Thank you, Margarida. Does anyone have a question for Margarida? Not sure where to start. Well, a very, very maybe naive question. Does the internet have to be fair? Is it illegal for Google to have unfair algorithms?
It's not. The internet should be fair because it would provide a better experience for everyone in it, but there is no legislation that enforces this.
Right. Okay. So how do you know if the specification the function that you've generated is the right one? Is there any way to validate that?
Yes, I do that during the synthesis process. Basically, I had these traces, and what I do is I come up with the CCA and I write a trace that is from that CCA, so that's my synthesized trace, and I have the real trace and I compare them, and they should be similar.
But,
that's how I know that it's
but
matching.
Maybe I don't have enough context, but the trace is just so a function is something that might be satisfied by many traces, right?
Oh, you're asking if there's more than one function that satisfies the trace?
Yeah. I was assuming there is.
Yes, we come up with the simplest function that satisfies the trace. And in the future, we will come up with the function that satisfies the trace best in an optimal way. That being said, we do make sure that our traces are taken in such a way that they represent the network conditions as much as possible. So the idea is that if a function will fit all the traces, we don't have just one, we have several. It should be what the CCA is doing.
Okay. Does anyone have a question for Margarida? Yeah.
So we are seeing you again. Great talk again, Margarida. So my question is, if you can show us your slide you had before, like with say your problem statement. Well, throughout the work, you say a couple of times that CCAs should somehow support fair internet and efficient internet somehow. But from what I understood, you and I guess everybody understands efficiency as time efficiency, like packets should arrive at earliest time. Mm-hmm. But so my question is, how far are we from this resource awareness also including, say, energy efficiency concerns, for example? Wouldn't this be a major revolution? Because, of course, this is everywhere, I think. So.
I'm afraid I don't really know how to answer your question. I don't work in networking. My part is the synthesis part. The evaluation of the CCAs is done by the networking people. That being said, I think they could evaluate the CCAs according to any measure of optimality and efficiency that they want. But I don't know if they have environmental concerns and energy concerns at the moment.
Okay, thank you. Does anyone have any last question? Okay, thank you very much, Margarida. Let's go on to the next project. So the next project is going to be presented by Luís Sá. He's a student from the Nova University, and we're going to switch to hardware from software. And Luís is concerned about hardware design and making sure that hardware is designed to behave as intended. Luís is being supervised by Bernardo Toninho from the Nova University and by Frank Fanning from Carnegie Mellon University. Luís, go ahead.
Yeah, thank you for the introduction. Yeah, let me just test. Okay, so, thank you for the introduction. So, my my talk is about the H calculus. Sorry. Which is session types for reasoning about hardware. My advisor at CMU is Frank, at Nova is Bernardo Toninho. They're both understand a lot about type systems. And I bring a new way of basically reasoning about hardware using type systems. So the contents, I want to kind of give you a broad context about hardware design first, before starting to see the details. I'm going to talk about the problem first, and then I'm going to say what my solution to the problem is, and the specific part that of the solution that I'm trying to, the sub-problem that I'm trying to solve. So the context is that hardware design is there's the end of the morsel, which is very important. So from like last year, from like 19, what is it? Yeah, anyway, we've seen the Moore's law, which is the law that it doubles the number of transistors per square inch every year. The Moore's law has been carrying hardware design since the 19th, and it's stopping. It's slowing down. The Moore's law is slowing down. So what do we do? With the Moore's law, hardware design kind of didn't change very much. They went from processors, mostly single core processors, and they just added more transistors and more transistors and more transistors, and they made these gigantic cores. But now that the Moore's law kind of ended, now we have to do something different. Now hardware design has to change in order to keep up with the performance. So now hardware design post Moore's law is very different. It's multi-core, parallelism, explicit parallelism, and the most important trend of the post Moore hardware design is actually custom hardware. So hardware is getting more and more specialized, and away from like the more general approach of hardware design. Now it's getting more specialized. So we already seeing this in most processors. There's the new Apple one, there's a neural processing unit, but even like the cell phone ones, like the Snapdragon processors, as you can see in the image, there are many different processors doing different stuff, and the CPU is just one small there. So it's a very different paradigm shift, and the trend is that hardware get more and more specialized. So there are computational problems right now, like many computational problems, that if you want to scale your performance, you will need to design a custom hardware, because software will only get you to a certain point. So that's the trend that's going on right now. So that's the background about hardware design. Custom hardware is here to stay, but that's also a problem, brings another problem, because designing hardware is very hard. That's it. It's just complex. You need to, and the traditional style of designing hardware, which is the RTL, the register transfer model, it is very low level. You need to specify the connections, the components, and you need to get everything right, the timing, concurrency, resource usage, and you're expected to do this the most optimal way. So regarding throughput, regarding resource, regarding power consumption, so it's pretty hard hardware design. So what people are trying to do right now is come up with high-level languages. Instead of designing your hardware with using RTL, which is low level, you should design in a high-level language, and then there's a compilation process that transforms it into RTL. The problem is that if you are going to like research about this, it seems to have to be a fundamental issue with this approach, because every time you want your high-level language to result in better hardware performance, you kind of give up a little bit of high-level abstraction. So you need to specify more things maybe. And on the other way, if you have something very low level like RTL and you want to increase the level of abstraction, you kind of lose a little bit of performance. So it looks like graphically there's just this kind of boundary that you can pass. And of course, what you want is high performance and high level as well. So so that's a problem. So a solution that I propose is to think this problem as two sub-problems, right? The first one is how to design better hardware. How designers design better hardware? The second problem is a little bit more low level, is how do we analyze hardware? How do we model hardware better? How can you reason better about hardware? And so I think that's the solution to the problem. But the exact problem that I'm trying to solve is the second one, is how do we analyze hardware better? How do we think about hardware? And what I'm proposing is something like the LLVM, but for hardware. So the concept of the LLVM is that there's a high-level language, you transform it to the LLVM, and the LLVM kind of deals with all of the optimizations, all of the low-level details, etc. So that's what I'm proposing for hardware. I'm thinking, okay, let your high-level language compile to something, which is an IR, by the way, an intermediate representation of hardware, and let another separate thing deal with the optimization, the analysis, etc. So, but in order for this to be possible, what is the IR, right? The IR must have, some characteristics. And that's exactly what my work is. What is the IR perfect for hardware reasoning? And that's the H calculus is this IR. So we built the H calculus. H stands for hardware, obviously. Not obviously, but yeah. And calculus, why is it a calculus? It is a calculus because it's a system, a framework, a system of rules used to reason about hardware. The same way that lambda calculus, for instance, is a system of reasoning about functions. So this is for hardware. And let me just... Yeah, sorry. So yeah, how does the H calculus does like what it does? Like, why is it good? It's good because it uses a type system, session type systems. Session types is a keyword. It is types applied to concurrent systems, and I'm applying them for hardware systems, which are concurrent as well. So session types, and the key thing about this type system is that it understands hardware, right? It understands that hardware has components. It understands that hardware is concurrent. It understands time. And one key thing about the H calculus types is that the types are very expressive. So but just by looking at the types, you'll know if the hardware, you can analyze the hardware from the types. From a type theoretical perspective, you can analyze the types, the hardware performance. You can compare two different hardware and all of these things. So yeah, that's kind of the summary. The H calculus is this intermediate representation that is ideal for hardware reasoning. So the details about the hardware, about the H calculus, I'm not going into too much of it, but it is a calculus with a type system. So there are terms, there are types, there are type inference rules, all that kind of stuff. And that's basically my work. And right now, what I need to do right now is to improve this work with help of Frank and Bernardo, who are they very much understand type systems. Also probably gonna collaborate with people like that understand more hardware, because my work kind of intersects both worlds. So I want to implement something. I haven't done this. I just finished the proofs and the theoretical part. And I want to test it, see if it works, if it reasons about hardware well, maybe implement an optimizer. And I believe that if we solve this part, the hardware analysis part, I believe we can solve the bigger hardware design problem, or at least understand it much better. And that's it.
Thank you very much, Luis. Questions for Luis, anyone?
Designing hardware is complex, and I suppose that your work can contribute to decrease the learning curve, right? I suppose this is one of the reasons why it is important. How do you add abstraction in your tool, in your framework, to control aspects such as loop unrolling, array partitioning, the use of fast memories? For instance, if you're testing these with FPGAs, the use of VRAMs or data types, quantization, et cetera. And the second question is, have you measured the utilization of resources in power and energy?
Right. So thank you for the question, first of all. So the H calculus is a language for reasoning about hardware. So it's not like I'm not yet building an optimizer, something like that. So it's not like I don't have results yet, right? The power consumption was better and stuff. What the language does is that if you have a hardware specified in the H calculus, you know how many resources are being used, the throughput, but not only the throughput, the inner details. You can analyze it pretty as complex as it gets with the help of the types. Also, the type system prevents that you construct the hardware in a way that it halts, or that there are communication errors, obviously. But the thing is that the hardware, the language, it helps you reason about stuff, right? It is not like an optimization scheme yet. It is to build optimization on top of the language later. So yeah, your first question was how do you determine array partitioning? All of these optimizations, you could specify them within the H calculus, right? And see the result of what happens after the optimization. See if what happens. So I don't know if I answered your question. The calculus, it has ways of defining memory and stuff, but the actual optimization you have to specify, right? And see what happens.
Calculus, but it's for another issue. I'm happy with it. Thank you.
anyone has another question? So I'll ask, we're kind of running out of time, so I'll ask you to be very short in your answer. So as far as I know, the session types and this kind of calculus has been initially created for software, right? Do you see any fundamental differences in applying this kind of calculus to hardware, as in compared to software?
A big part of the work was exactly fixing the parts that don't make sense for hardware and keeping the things that make sense and adding more stuff in order for it to model hardware better. So that was a big part of the problem.
Okay, Luis, thank you very much. Let's move on to the next speaker. So, Cláudio Gomes is a student of Universidade do Porto. And Cláudio is worried about supply chains and optimizing supply chains. And in particular, Cláudio wants to make sure that they are sustainable. And the twist is he wants to use quantum algorithms to do that. He's being supervised by João Paulo Fernandes, also from Universidade do Porto, and by Sridhar Tayur from Carnegie Mellon. His work is called Quantum Computing for Sustainability. Cláudio.
Okay, so thank you very much. So I just entered the CMU Portugal program as a dual degree PhD student. So my goal with this presentation is to talk about the work plan for my PhD. And I hope that I can give you the motivation and the general overview of my work plan. So I will talk about me first. I just finished my master's in informatics engineering, and my thesis was about portfolio optimization in financial markets using quantum computing, an experimental study. So as you may have already guessed from this, my main interest is quantum computing. So for my PhD work plan, my main objective is to find a way to apply quantum computing to a real-world problem that, with the hope that I can improve in some way our daily lives. So I want to give you the starting point of my work plan, that is supply chains. When we talk about supply chains in the past, companies had one thing in their mind, that is to maximize their profit. And so the supply chains in the past were designed to be as fast as possible, as responsive as possible, and as inexpensive as possible. So, however, all of these come with a cost. These supply chains usually lack sustainability. The company did not take into account the environmental impact of the supply chain. And these supply chains also lack resilience. So when any event puts strain in the system, the supply chains are usually not able to cope with the event. So I'm talking about the events such as the every given ship that got stuck in the Suez Canal, affecting supply chain all over the world. And something happened with at the start of the pandemic, where people were buying toilet paper in a mass panic movement. And this type of event will continue happening in the future. So when designing supply chains, we need to take into account this event because they will for sure happen. So there are already some examples affecting us right now. For example, there is a chip shortage that is affecting phone manufacturing computer manufacturers, and even car manufacturers. In the end, consumers are facing higher prices, and this is a situation that we should avoid in the future. There is also another situation that is happening from a sustainability point. That is extreme climate events, such as New York, for example, faced heat waves, and they had to spend colossal amounts of energy to reduce temperatures to a comfortable level. And this necessity puts a lot of strain in the electricity system because they need to anticipate these needs, and it is becoming increasingly difficult to do so. And this is another situation that supply chain need to take into account. Okay, so this, in the end, this is a challenge for us. We need to design supply chains for the future that are designed to be sustainable and resilient. All of this while maintaining the profit and the responsiveness. Okay, so this is where quantum computing comes in. Quantum computing as a field of computing brings a new paradigm that opens new possibilities for optimization problems, because we can solve this problem in a shorter time and with better answers. And this by itself lets us solve optimization problem in a more efficient way. And the same principle happens with quantum-inspired algorithm. We can grab a classical algorithm and take inspiration from quantum computing to improve our results or to solve these problems in a shorter time. And of course, all of this will help us combat climate change. Okay, so how can we do this? We can start, for example, by minimizing the carbon footprint of our systems. For example, data center. We transmit a lot of information all over the world with a lot of processing associated. And so if we find a way to solve the optimization problem in a shorter time, we spend less resources and energy at solving this problem. And thus we are minimizing the carbon footprint and also increasing the resilience of the system. The same thing happens with fleet vehicles. These vehicles are dependent on routing problems. And if we design a new algorithm that find routes in a more efficient way, we spend less fuel driving these vehicles, and thus minimize the carbon footprint. And the same thing happens with the communication. We have an extensive communication network all over the world. And if we find a way with quantum computing to increase the safety of the system while spending less energy communication with other people, we are minimizing the carbon footprint and increasing the resilience of the system for potential attacks. Okay, so this is the general overview of my work plan. I want to say that I'm just getting started, and I welcome any feedback. Thank you very much.
Thank you. Thank you, Claudio. So I'm going to translate every question to Portuguese to help Claudio lip read. Does anyone have a question?
Perhaps I can make the question.
You can do it in English, in Portuguese, to make sure everyone.
Okay. Thank you,
maybe
yeah.
Without the mask.
Yeah, without the mask. Thank you, Flavio. Very interesting work. I was wondering why I think that choosing sustainability as your real-world problem is really a right thing to do. And my question is why combining sustainability with supply chain, because it seems that it generates an additional amount of complexity that perhaps just looking, for instance, at distributed energy could be a possibility. Eu vou fazer a pergunta em português agora, para tentar perceber melhor. A minha questão é, primeiro, parabéns, acho que é um tópico muito interessante e acho que escolheste um problema difícil e importante. A minha questão era tentar perceber porque é que estás a combinar supply chain com sustainability. Porque há muitos outros problemas dentro da sustentabilidade que se calhar são suficientemente importantes, não precisas ter a segunda layer.
Acho que a pergunta é porquê é que estás a juntar supply chains com sustentabilidade? Porque isso estás a adicionar um nível de complexidade muito grande e podias estar a pensar em problemas de sustentabilidade esquecendo a parte de supply chain só para reduzir o tamanho do problema. De supply chain. Como é que se diz supply chain em português? Sim, pronto, a sugestão é, a sustentabilidade já é um problema grande demais. Porquê é que estás focado no subproblema da sustentabilidade e não escolheste outro problema e te sugeriste um outro... Energia. Só focaste na parte da energia e não no supply chain.
Okay, so I'm focusing on sustainability because I think that there is a movement from companies to focus on reducing the carbon footprint, and so this is the reason behind my focus on sustainability. Because I think that it will have the most impact in the industry. Okay. Thank you.
Any more questions? Let me ask a question. I will ask it in English and then in Portuguese. I have two questions. Is quantum computing more suitable for certain optimization problems? A computação quântica resolve melhor alguns tipos de otimização do que outros tipos de otimização?
Okay, quantum computing in the current state is not able to solve optimization problem at a great scale. And right now there are a specific type of optimization problem that it is better suited for. However, there is some inspiration from quantum computing that you can take and apply to classical computing. And in the end, you can get improvement in any type of optimization problem. Okay.
More questions? So I have a final one. I was already discussing this with João outside. How do you, since there are no quantum computers are not available for you to use, not at home, not at the university, how do you plan to work? What will be your process? Visto que não há computadores quânticos acessíveis para nós usarmos, qual é que vai ser o processo que tu vais usar durante o teu doutoramento? Como é que vais fazer durante o teu doutoramento? Vais usar computadores quânticos ou vais fazer só simulações?
My main objective is to be practical. So I wish to use real quantum computers during my PhD. And I hope that during the years of my PhD, quantum computers will evolve at a point that let me able to use in real world problem. Until that, I will take inspiration from it to classical algorithms. And that my process will be studying it. finding if I can use it already or not. And if not, if there is an inspiration that I can take from it.
Cool. Okay. Any more questions? If not, thank you very much, Claudio. Thank you, everyone else. This is the end of the session and the end of the day, I think. Thank you.
Okay, it's my turn to close the session and the day. It's already been, the afternoon has already been long. I would just like to first to thank, the people that have been chairing these sessions. We had, as you know, we like to make this connection with industry, and we had many people from industry chairing the sessions. I think it's a good way to try to approach this new generation of young students with industry and the real world problems. I was very pleased to see many of you. Many are already starting, but already very confident in the way they pose the problems. I think most of the presentations were very, very good. And like our guests in the beginning of the session said, you are the best of the best. So take this opportunity really to make a difference. Don't forget about your country, because you're being at Carnegie Mellon, you'll be going to be subject to a lot of opportunities to stay there or go elsewhere. Don't forget that you're Portuguese, and that we hope that you will come back and change the country like many before you did. So again, thank you very much, everybody. Good luck. We are always here if you need anything. And this is also an opportunity to meet each other and to cross different disciplines. So don't forget about that. Don't just stick to your topic. Try to look around, because there is a lot of cross-pollination happening. Thank you. Goodbye.